Hi everyone. So in this video we'll see how to install the Conda mini Conda in our local computer. So you can do a Google search and search for Conda. There is a documentation. You can directly go into the installation page, and in the installation page there is a system requirement. So you can either download 32-bit or 64-bit as per your computer configuration, and you can then select what is your operating system. So I'm currently on the Windows, so I will click on the Windows. And here there are two versions, the Mini Conda and the Anaconda. So Mini Conda is just what the base version. So we can click on that and it will download. To download this Mini Conda, you can select. I'm on the 64-bit, so I will click on this and we start the downloading. So within a few seconds, download is complete and we can click on this. And it says the installation process has started. So click next. You can read the terms and conditions. For now, I will just click I agree. Install for will keep for me as well, just me. And I will keep as the base path. I will not change the destination folder. Click next. So here are the few options. Create a start menu shortcut. Yes. And the next one is the add mini counter to my path. So let me add that because it is you can, as it says, not recommended because this can lead to conflict with other application. Instead the command prompt and PowerShell menu to add to the Windows start menu. For I will just do it and click next. Setting up the package is started. Okay, it will take few seconds. Click next. Cool. And let's verify. So we have a prompt now. Can type Python. Yep. So we have installed the mini version of Conda. And if you want to install the any packages, so what you can do, you can you either use the conda install package name syntax or pip install package in package name syntax. So if you're using conda, the recommended is you can use the conda update package name if you want to update the package, and if you want to install again the conda install package name. Also, if that is not supported, you can always use pip install package name. So that's how you install the mini anaconda in your locals. Thank you. Hi everyone. So in this video, I would like to talk about some of the Python basic before we start into the data analysis part. And in the last video, we installed the Conda, and if you don't have the Jupyter Notebook installed, you can just run this command conda install Jupyter in the command prompt, and you will be able to access Jupyter Notebook after that. So before we start, just a brief intro about the Python. So Python is the programming language, and it's an interpreter language. Means in the interpretation, every instructions get interpreted one by one. So it's not like a compile-based language like a C, C++, or Java, where first the your code is get generated into the compiled base code and then to the binary. Next, let's do the ritual of writing the print hello world, right? So print is a statement where if you provide anything, it will just print out. And now let's talk about the variables. So variables are the character where you assign the values. Like in this case, I'm saying a equals to 5 means I'm binding the value 5 to a, right? If I type a, that gives the output 5. So this is the input field where I'm entering the command. I have already written this command and I'm just running with shift plus enter. And this IN represent the input, output represent or UT represent the output. So this is the Jupyter notebook. If you have not seen, you can create your new file, and also there are few commands. I will in between I will tell you which are most useful commands in this. So again, to install the any library in the Python, here you can write pip install and in your library. In this case, I'm just installing the NumPy, which I've already did, right? And to import, you can just write import your library as is the just to give alias np. Np is the very standard form which everybody use for NumPy. What I'm doing here is I'm just creating getting the random values from standard normal distribution, 7 values, and I'm just iterating those and putting into data variable, right? If I just run this, I should get the 7 values. So these are the 7 values from standard normal distribution, and it is storing into the list. So they've again just to give you a few features of the Jupyter Notebook. So there are tab completion and intersection. What is a tab completion means? So in this case, suppose I have already created a data, it is in the memory. So if I just write DA and put a tab, so it will autocomplete. So that's is mean by tab completion. Okay. And next is the introspection. So introspection is nothing but so if you want to get more detail, right? What is this data? You put a question mark and type a data. So it will give a detail of what is this a type of list, right? As I told, it's a list of 7 character length, and it's a built-in mutable sequence, right? You can change mutable means you can change it, update it, and if no argument is just a detail about what is the list all about, right? And I have also had the a in the memory, so let's put that. So a is the int type, it's a string form of 5. It's a doc string. What is the int x you put in, it will convert it to integer, right? Now why this is important. So let's say you have created this function. So we'll talk about function detail in the next coming videos. So def add number is the function where it is taking 2 arguments, and we have provided a doc stream add 2 number together, and it's returning the sum of type, right? Let me run this. And now let's see what what happen if I just want to know more detail about this add number, right? As you can see in the doc stream, whatever I have written here is coming here, right? Add 2 number together and it's return the sum type of arguments. Now also you can it will help as the while string character. So while string character is nothing but, let's say I want to see in the NP library what are the functions which have attributes or method which has load in it. So this it will search LOAD in the NP library. So as you can see, there are underscore loader, load txt are the 3 type of attribute or function methods are available in this library. Now let's move to the next, the language basic. So Python uses the indentation not basis. So in the programming language like C, C++ or Java, so it is there is a curly braces where you wrap around your code. In the Python, it's indentation. Semicolon is not used to end the statement. So in again in the languages like C, C++, you put a semicolon that represent the end of a statement. In the Python, it's not. Everything is object in the Python. So whether you create a variable, the function, class, everything is object. And we'll talk about more this. To put a comment like this, we use hash symbol. So this will not be interpreted by the Python interpreter while execution. Variable and argument passing. So again, I have a example, and dynamic for, again, for dynamic reference and strong type. There is example. So let's see what is the mean of the indentation. So I have written this as a for loop, and after a colon, so you can see there's a space, right? Space. So it's a mostly a four characters, and this is what the indentation. So whatever the block, it's the colon represent the start of the indentation. Okay. So if I just run this, it will show 1 to 7, 1 to 6, 0 to 6, the integers, and just printing those. Now semicolon is not used, but you can use the semicolon to, uh, instead of moving to the next line, you can put a semicolon and start the uh, next variable if you want to assign some values, but it is not encouraged in Python. So here the value of A is 5, value of B equals to 4. What is mean by the variable and the argument passing? So let's say if we have a list A, it has three values, 1, 2, 3, and we are going to print A. Now what we are doing, we are assigning A to B, and we are also going to print B. So what this means here, the B, there is, what B is doing, B is referring to the same list which is passed to A. So this is not creating a copy of a new list. Okay, and we'll append 4 in this list, and the output should give the same values, 1 2 3 4, 1 2 3 4 at the end. So let's run this. So as you can see, the first we have assigned, we have printed A. Next we have assigned A to B, we printed B. We appended value 4 in A, not in B, so it appended here. And as you can see, the A got updated and also the B got updated because it is referring to the same list which is available, which is assigned to A. So it's a strong type. So if you want to see, we are assigning 8 to 5 to A, and we want to see what is the type of it, right? It's a integer type. This is string type. And what happens here? So we are in doing the summation of 5, that is in string format, plus 5. So in some programming language, it can convert into 5 plus 5 10, or 5 plus 5 is a string 55. But in the Python, it's going to throw you an error. It says you cannot concatenate string to str. Next is the A equals to 4.5 and B. So in this case, as you can see, the output is converted into float, right? You can check whether which object is belong to which instance, right? So in this case, A, whether A is int, it will be false because A is what? Float. A is float, it should true. Now, so what we are doing here, we are creating a string called S, right? Let me run this. It's a string. Now, if you want to see, it's a type of string, right? So let me do str, right? So a string has own attributes and method, and we can access those with the dot notation. So if I just put s dot and tab, you see there are a lot of functions which are available you can use. So this is called the attribute and the method belonging to that particular object. Next is to check whether the object is iterable or not. So what is mean by? So there are many objects which are iterable. Means if we create a list, it is iterable. You can access each element, right? You can access the, if a string, you can access it. So let's run this function, and I'm using the object. If it is iter is the built-in function which is going to give return true if it is iterable. So a string is iterable, yes. List is iterable, yes. For is iterable, no, right? Because you cannot iterate or the int single element. What is the import does? So just import the Python code which is written in the some other file, right? Even in the case of the library, so library is nothing is the collection of your Python code, right? Written by somebody else and you are just using it. Like in the case of NumPy, we have imported NumPy and the objects. So in this case, in the sum module, I have one variable pi, its value, and two functions. Which one is adding the multiplying it by 2 and second function is doing the summation. So what I'm doing, I'm doing just in importing this sum module as sm is the alias. So alias is as what I'm doing is I'm just importing it. What is the pi value? So 3.14. So this f function is going to multiply by 2, right? This is going to do summation multiply by 2. There are arithmetic operation you can perform using Python. I will not go, this is very basic, plus minus divide modulus, everything is works as like other programming language, like 5 minus 4 is minus 4. Though I would like to focus more on this mutable and immutable object. So mutable is object means you can you can update it, right? Like list you can update, right? With string, no, you cannot update because string is immutable in Python, right? So let me give examples. I have created a list, right? It has one string, one int value, and inside one more list. So let's run this. So this is what the list about, and I want to update the sec second. So it's will start with 0, 1, 2. I want to update this list with tuple, right? Let's do that. I'm able to do that? Yes. Next is the string. So we have created a string and I want to change the third, means starting with fourth. I want to change to, let me write F, something like that. Am I able to do that? No, because string object does not support items assignment. It's a immutable object in Python. What about tuple? So let's create a tuple, right? And I want to change 0, 1 to 4 to 3. Can I do that? No. Again, the same tuple object does not support item assignment. So what I'm doing here is let's move to the object type available in Python. So first let's see the numeric. So it's a numeric. I'm raising it power to 9 and as you can see it's a very big number it can handle, right? So 3 divided by 2 should be 1.5. And uh, if you want to do the floor division, right, you can use the double forward slashes. So what is happening? So it is discarding the after decimal values. String we have seen is to create a string 1, string 2. You can do that. You can even concatenate with plus, right? If I just write as plus as 2, it is just concatenating those. If you want to create a multi-line string, you can use the three quotation marks, right? One, two, three. And interesting thing here is there are three separate lines. So one, two, three, right? So if you want to see what are the new, how many new lines are there? So it's three here. Next, as I told, string is immutable. You cannot change the string once you create it. So just to give an example, we have created a variable assigning this string to it, and we are going to print it. Next, we are going to create a new assign a value by replacing a with longer and assigning to b. So let's see if all strings are same. So even after replacing a here in the a string, right, it still remain the same. So it's immutable. You cannot update it. Next is to convert numbers to string. You can do that using str function, right? This function. So we are assigning a int here, and we are converting those to string using str function. So string is also iterable, as I told. If you want to access string elements, right? In this case, I want to see the second. So 0, 1, 2, 3. This is what we are getting. We can convert into a list, right? Next is the escape character. So the backslash. Let's say we have a backslash 1, 2, 3, and you want to retain this one, right? It is 1 2 3 divided by 3 or backslash 3 4. You can use the one additional backslash which is known as escape character. So one will retain and one will escape. So like this. Let's say you have a file path, right? In this case, if we run like this, so you see what is happening here. It is taking, it is slash and is taking as the new line character, and that's why it is coming to the new line. But I want to retain this as whole. So what is the method you can use? You can use the R, which is known as raw, and it will tell Python to interpret as this a complete string, right? Don't consider this as a special character. So you got the same output. Next is string format, very important. So the I'm just assigning this values to template. So what is this mean? So this means the take the first argument in the format. Format is the inbuilt function. Convert into the float. Take the second means one. Convert into string, and second to the decimal. So if I do template or format, put this value, so it will goes here, it will go here, and it will go here. Let's see the output. See, this is converted to float with two decimals. This is to string, and this is to the one value. Now in the new version of the Python, you can there is something called f string. So you put a f in front of it and put a bracket where you want to change the value. Like in this case, amount value will come here, currency will come here like this. Boolean is true false, so true will give you true or false give you true, right? Int, and when converted false to integer it will give 0, and converted true to integer give you 1. None is a special type of value in Python which represent the null value, so you can also assign that to a, right, and check whether a is none, it will true. B is equals to b is none, false. And it can also use as the default value. So in this case, what we are doing, add or multiply, means add this number, and if this is value for C, then multiply that result. So let me run this function. First I'm giving 2, so 2 plus 2 it should give me 5. And in this case, in the next case, I'm assigning this value. So what should give 5, 3 plus 4 7, multiply by 2 14. Date and time, very important, and heavily used in the data analysis and time series. So date and time, we are using the date time library, importing the date and time. And here what I'm doing, I'm just assigning a value to dt of date time, giving 2013, year, month, day, hours, minute, second, right? And if you want to see what is the day here, so day is what? 3, right? What is the date in this? The date is this part, time is this part, right? Let me run. Date is 3, time is 3. There's a two methods very important to convert the date into string. So strf to time, right? So let me convert this into string. As you can see, the time in this format uh, convert into string, and you can do the reverse. You can convert this string into the date in this format. For that function, you need to use strp time. So you see the difference is strf time and there is strp time. Right, so also let's create a new uh, date, and what we can do, you can you can divide sorry, you can add and uh, do the subsection of from the date. So d2 is the 2013, and we want to see what the difference between the d2 and the dt2 and dt, and putting into the delta variable. So there is a difference of this many days and this many seconds. And if you assign to a addition of d2 plus delta, so you should get a value of d2, right? You get the same value of this. Control flows, so this is what we have very similar to in like in the other programming language, the for loop, right? If and the while. So let's talk about the if else, if elif and else. So if is the condition where you put down condition, if it is true, then the next block of code is executed. So in this case, if x is less than 0 is a negative, it is greater than equals to 0, it is 0. If it is less than 0, if it is greater than 0 and less than 5, it is positive plus less than 5, else it is 5. So in this case, if we are putting value here x equals to 9, so this block code if executed. So let's put -2, let's say negative, and let's put 0, let's say 0. So for loop is nothing but the syntax here is you have a for loop for keyword, the value which will one by one it will come from this part, from this collection, and we have a next block of code to be executed after that. So here what we have is a sequence. So it's a list 1, 2, 3, none, 2, 3. So here what we are doing, we are just printing this, right? We are taking value one by one and printing it, right? Now we want to put more condition. Let's combine the if part here also. If value is none, then continue. Continue means it will skip that part, skip that value and move to the next value. So in this case, we are doing the total. So if you do the total without if condition, so it will go through an error. But in this case, you will get value 12, right? So if you don't use if and if you want to try to do a total, it is going to throw an error because you are adding the none type. None type is nothing but a null. Break is nothing but it will break when the condition is met. Break means it will get out of a loop. So in this case, what we are doing, we are printing value I starting from 0 to 3, right? And z from 0 to 3 and printing it. So 0, 1, 2, 3, right? So 1, 2, 1, 2, 0, 1, 2, 3. So let's start with now we want to restrict it. So if z is greater than to 1, means this value is greater than 1, then it should skip, right? So let's see. So you see after it is becoming greater than 1, it skips and move to the next values. While is nothing but it has a condition and then the next block. So until this condition is true, it's going to keep executing the code, right? So in this case, the condition x is if x is greater than 0, right? Then print x. If total is greater than 0, break means get out of this loop. Also, just want to have highlight the range. So range is nothing; it generates the sequence of evenly spaced integers. Means if I just write 10, so it will generate from 0 to 10, right? You see, it's generates 0 to 12. 12 being excluded means it start with 0 and 12 characters. And you can convert this into list. So what is happening here? So this is a start, this is the end, this is a step. Step means it will skip four lines. So 0, 4, 8, 12. If you put a 3, then it will skip 3, right? Let me change that, show you like this. Now just to end this, let's add the number 0 to 19, 0 to 999 and multiply with the multiples of, if it is a multiple of 3 and 5, then only add it. So it will go 0, it will take one value, check whether it is divided by 3 instead of multiple of 3 or multiple of 5, then add it, right? That's how you get the final number. So this is a very basic of Python. We'll continue the basic in the next video too before we move into the more data analysis part of it. Thank you guys. Hello. So in this video, I would like to discuss regarding the data structures which are available in Python, and I will start with the tuple. So what is tuple? Tuple is the immutable fixed length object. And what we mean by immutables means once we define the tuple, we cannot change the element in it, right? So to do that, we use the brackets, normal brackets. In this case, tup, we are keeping three elements, 3, 54, and 3. And if you run it, so that's the tuple. And likewise, you particularly don't have, if you don't put the bracket, then still it is going to give us the result as the tuple. In this case, A equals to 3, 45, 5, and the result is a tuple. You can also build the tuple using the keyword tuple. So in this case, the string is the elements which we are putting in tuples, right? And if you run it, you will get the each element as the new, each word as the new element in the tuple. Tuple is iterable, means we can access each element of the tuple. So in this case, if we are putting, give me the third element, so it's a zero index, 0, 1, 2, 3. So we should get I, right? We can, it is iterable, we can access each value. So in this case, in the top, we are iterating our top. So each value will be printed string like that. We can concatenate tuple with another tuple, right? And it will result in this string plus 35661 as the new element. You can do the unpacking of the tuple. So what do you mean by unpacking? Means each, if you assign, in this case there are three elements in the tuple, right? And we are assigning three additional new variables. So each value, so what the value of A is going to be 2, and B is going to be 4, and C is going to be 5. So if you run it, A should give the 2. Swapping in Python is pretty easy as compared to other languages. So in this case, A, B, we are assigning, we are just swapping the values of A to B and B to A. So earlier it was 2, 4, now it is 4, 2. Sequence. So sequence is again, it's contain three tuples and each tuple has three elements in it, and we can unpack this means A, B, C. So the first element will come here 1, 2, 3, and it will assign value of A equals to 1, B equals to 2, C equals to 3, like this. This is an again the interesting part. So let's say you have a list which contain many elements and you are interested in the first. You have two variables A and B which will take the first and the second value of the list, and the rest you want to keep as the in some additional in new variable, like in this case the underscore. So what will happen? A will assign to 2, B will assign to 4, and the rest, struct rest, whatever you, underscore is 1, you can put any value, and the rest will be 521 11. So if I run this, so this the A got assigned to 2, B to 4, and the rest are to underscore. The methods in the tuple are very limited, only there are two, the count and index. So in this, if you want to count how many ones are there, so in this case 2, so we should get answer 2, right? Index, what is the index? 5 is uh, what, at what index the 5 element is, right? It's on the 2 0 1 2. So let's move to the next one, the list, very important and heavily used in the Python. So list is the again contain multiple element, is a mutable. You means you can change the element in the list, right? So we are creating a list of 1 4 7 and none here. You can, what you can do, you can convert tuple into the list by putting the list as the into the list function, right? And this will give you the strng in the list format. Earlier we have converted into tuple, right? The same thing. Now let's do some operation, adding and removing element, adding and adding. So use append and insert. Append, you will just append at the end. Insert, you put, you specify the location where you want to add. Remove, you pop, so it will pop the first element, and the remove, it will remove by specifying the location. So it's, I just append 0, so it will give 145. 0 is added at the end, right? I want to insert 10 at the 2 means here, right? So let's do that. So 5 got shifted and 10 got adjusted between 4 and 5. So let's do the pop. So pop, so 1 got, first element got removed, and we want to remove 5. So the fifth element got removed here, right? And the list is now 4, 10, none, 0. You can also check whether the particular element is present in the list or not by using in keyword. So 0 in list, yes, it will return true. 100 in list, no, it will false. 10 100 not in list, we are just negating it. That's mean true, right? You can concatenate a list with another list by using the plus keyword, and also there is a function called extend. So I will show you both. So here we have appended 4 5 this additional list to the existing list. Now the next part is the we have appended 3 4 34 using the extend function. This is more preferable due to because of the resource expensive. The plus sign is very more expensive operation as compared to the append because it takes create a copy and then append it. Next is the remove. So let's remove none, right? And we can also sort using the sort function. Slicing is again very interesting. So this is a list and I want to only see the this part, right? Start with 2 4 7 7 3. So how do you know how many element is going to return? So what you can do, just take this minus this means stop minus start. So in this case we are returning 3 elements. Most important data structure I would say in the Python is dictionary, and it is again it's mutable. The only difference is start with the curly braces. It's a key and value relationship in the dictionary, means there is a key and key has values which can be a list, which can be additional dictionary, which can be a tuple, anything. Right? Let's create an empty dictionary like this. So we use the early braces to create the dictionary. Next is let's create a dictionary D1 where A is here is the key and this is the value is the list. B is the key and 3 4 is tuple is the value. So let's run this. Right, this is how comma separated and key value pair is there. So how do we insert? So this is the key and this is the value. So it should append at the end, right? And we can again like the list, you can check whether the this key is present in D1, 3 is present in D1, true, 4 is present in D1, false. D1C equals to this, right? We are just adding that one more. Let's add one dummy value. We have a good list. And now how do we delete the values from the list? So what you can do, you can use DL first keyword, your dictionary, and the key which you want to delete. So in this case 3. So now the C string is got deleted, right? Or you can just pop the value with the value with a key. So in this case we want to remove this. Pop dictionary dot pop and the dummy value is gone. So if you want to extract what are the keys available like A, B, C, right? So you can do keys. If you want to get the values, you dot values is the function. If you want to see both in the pairs like 2 to its A and its values, right? In the tuple, so you can do like that. So you can see it is a list of tuples. How do we update the dictionary? So to update the dictionary, there is a function called update. You the dictionary D1 dot update and the D I want to add one more, right? And E, two more elements. So D and E got added. Creating dictionary with sequence. So what here doing? We are using zip. Zip takes two sequence of one in this case 0 to 3 and in the reverse 3 to 0 and it's going to make a tuple and the dict is the keyword where how you use to create the dictionaries. So let's create the dictionary for the word actual dictionary. So these are the words available. So what we want to do, we want to create a dictionary and take this first word and append means this will be the key and this will be the value. And if key is already available, it will the next word. So in this case, atom will be appended to this one, right? Like this. So what is we are doing here? We are calling each value. So in this list, word is coming with apple. Apple from A is extracted and put into letter, right? If letter is not there in the dictionary, means it's not there, currently it is empty, then it is going to update this with letter means A, and the in its word, right? And if it is there, means if A is already available, it will just append the one more word. So that's how we create it, right? So in this case, we have added more. We are creating using the set default function, which is available in the baseline itself. So you can, what you can use the dictionary dot set default, the letter, and it will create the first empty list and then keep appending the values. There is one more there is a actual from in the collection library there is a method called default text which do the same thing with less lines, right? So it will give the same result. It will just use the default dictionary as the functions available. Now, why this is so keys in the dictionary need to be immutable means hashability. So as you can see, what we are using here, A, B, C, S, C, S, O, P, all are the keys which are immutable. Means you cannot update this one, right? So how do you identify those? So let's see whether we can use string, right? Hash, it has a hash value. Tuple, yes. List, no. Unhashable type list. So list you cannot use as the key in the dictionary. So one way to do that, if you want to use the list, you can convert into tuple, and tuple again can be is a hashable and can be used as a keys in the dictionary. What are sets? So set is the unordered collection of a unique element. So let's say there are 1, 1, 2, 3. So in this case, the output, the set is the 1, 2, 3 is a set of the values. So how to create a set? So use a keyword set, and in this case it will just remove the duplicate. So in this case 1 2 3 should be the answer, right? Again 1 2 3 4 unique values. So there are many operations like in the SQL you can use a like union. What will do, union will remove the duplicates and give the all values in A and B. So let me run this and see. So A dot union B, which means give the unique values in the boss set. So 4 5 3 4 is the duplicate, right? So it will not repeat it. Intersection means it will only give which are matching values. So what are the matching value? 3 4 5, right? These are the three matching values here. Difference, what is the difference in this? So it is 1 and 2 because these 3 4 5 and in the A 1 and 2 is also not available. A is difference how? So 1 and 2 is not available. So if you do B difference A, then you will get 7 and 8. A is a subset of B, false. Let's create a new and if we see C is a subset of A, it gives true. So that's the major part of set. So to summarize it, we have seen the major data structure which are available in the Python. First, we have seen what is tuples, right? Mutable, immutable with the normal brackets, list, mutable with square brackets, dictionary, mutable with curly braces, sets, which belongs to the unique values in it, and you can do more of SQL like functions, operations using the set. Yep, more in the next video. Hello. So moving our discussion from the previous video, I would like to discuss more about the built-in functionality of Python. And let's start with the numerators. So what the numerator does, it returns the specific sequence of index and the values in the tuple. So when we do iteration of a list, the for loop, it will give you the element of the list. And if you want to index, you can use the enumerator. So for example, so here we are generating one sequence from 0 to 40 with a step value of 4, means it will skip 4 values, right? 0, 4, 8, 12, 16. And if you want to get the index, so what the for loop does, it will take this element out of it, and whatever operation you want to do it, it will do it on this. And if you want to know the index, means whether it is 0 1 2 3 like this, you can use enumerator which returns the index, right? So let me run this for loop. So as you can see, 0, 1, 2, 3, 4 to 9. So these are all the index which are generated by the enumerator on this sequence of list 0 to 40 with the 4 skip values. The sorted, what it does, it returns the new sorted list. So what it will do, it will sort the values based on the alphabetic. So Z comes before I comes before N, likewise. Zip, very important. So what zip do, it will pair the elements. So let's say you have two sequence 1 and sequence 2, in this case foo bar bus, and the sequence 2 is 1, 2, 3, and you want to make it, you want to zip these two, means you want to assign 1 to foo, second to bar, 3 to bus. You can do using a zip method, right? Let me run this, and as you can see, it created tuples for each, and I have clubbed into the list using the list function. Now you can do more. So in this, I have created a sequence 3, false and true. What it will does, it will create a 2, means it will include the false part also into the zip, right? 4 1 false and bar 2 true. So why there is no third, because in the sequence it is only a 2. So that's why it truncated the third value from the previous two sequences. Same thing you can do for the dictionary. So in this index, and we are creating a tuple of A and B. So like this, index 0 will have a foo 1 bar. We are using these two sequences, and 1 2 will be in the one tuple, 2 to bar into next tuple, and 3 to bars in the third tuple with the index 2. Reverse is nothing but it will reverse this the list. In this case, if you put a reverse, instead of showing 0 to 9, it will show 0 9 to 0 in the reverse order. List, set, and dictionary comprehension. So comprehension means doing more with less code. So you can either you can write multiple lines code, or the same thing can be done using the single line code. For example, in the syntax is for loop. So it starts with their for loop value in collection. Go check for if any condition and then do the expression. So in this case, uh, iterate from 0 to 100 and check whether it is divisible by 5. If yes, do the multiplication by 2, right? Like this. So 0 next is 5, right? Multiply by 2, 10. Similarly, you can make a letter uppercase if it is length is greater than 2. So in this case, bat, car, dove, python will be uppercased. Similarly, in the disk comprehension, the syntax remains the same. You have for loop, for iteration, check for condition, and do a key value expression here. So in this case, we are enumerating from range 2 to 11, checking whether it is divisible by 2. If yes, the value should be multiplied by 2, or let's raise the power 2 in this case, like this. Now you can do the same thing for the key and value for the string, and for each string will be string we have a, right, and it will what it will do, it will key, what is the key, 0 1 2 3 4 5, and the values which are there means it will get as in into the dictionary format. Set, same thing, but in this case we are using the length, right, length of the key, and let's the string, you can see it, what it will do, it will get each element of the string list, right, get the length and stored into the set. And what does set functionality do? It will remove the duplicates. So in this case, the bat and car has three as the length, right? But here we are showing only one element because it's a set. The other way you can do is the map function. So what map function do? It will take the function and the object you want to use in the function. So the string one by one, the string values, the element of the string will go into the length function and put the output as a set. Same thing. Nested list and comprehension. So suppose there is a nested list is there. So list and the what do you mean by nested list? List within the list. And you want to use the list comprehension. What you have to do, you have to use additional for condition. So this for value for all. What it will do, it will from all data list, it will get the values means first list, second list, and on the first list, the next four for loop will take each value from first means from John, right? John, Emily, Michael, Mary, Steve, and then do a count. So if it is A is available is greater than or equal to 2, it will store the list. So in this case, how many we should get? We should get 2 because Maria has 2, Natalia has 2, more than 2, right? So that's what we are getting. Now let's move to the next part of very important object in Python, the function. So what do you mean by the function? Function is nothing but, let's say you have a block of code statement which you want to run again and again. In that case, it's better to club those into the function, means make a separate block of statement which you want to run again. And what is the how do you do in Python? So you use the def code to initialize, means you want to make sure this is the function and a b are the argument, means which are the input. These are the operation, means it will return a plus b. So in this case we will be giving two variables a and b some values and it will return the summation of dot. So let me run this. So 3 plus 4 should be 7. Next is the positional and the keyword argument. So keyword are we are giving the default value and positional and a and b. So in this, as you can see, I'm only giving one argument, right? 4. So what will happen? It 4 will automatically assign to A. B already has a value and it should give the value 7. Moving to the next is the namespace, scope, and local function. What do you mean by that? So local scope means in let's say if we assign any create a new variable within this function, the scope of that variable will lies within this function, means it will not go outside. So you initialize the function, the this get generated, means a will get generated, and you will see with this value only within the function. So this function does, it will take the range, means 0 to 4 values or append those into this list. So let me run this. So I got this. Now I want to assign this. I want to check whether what are the values of AA. Can I do that outside? No, because A is not defined. It is only defined inside the function. That's what called local namespace. Now, how we can access the A part? So if you define A outside the function, right? So let me change the name A here so we don't get confused. So A, what is doing again 0 to 4, it's appending the values into this. Can I run that? Yes, same output. Now, can I access AA outside of this function? Take a guess. Yes, because this function, this AA list is outside the scope of this function in this namespace. You can return the multiple values from the function. So in this case, ABC is got signed 1 to 3 and I'm returning this, right? And it will return three separate values as the tuple. So you can do that. You can return the multiple values from the function in Python. Functions are object. So what we have here the state with Alabama, Georgia, and you can see these have some kind of a mismatch in the name. There is a question mark, there is a hash symbol, there is a exclamation mark with the name. So if you want to do a cleanup, and we will do more in the coming video of the data analysis, how to handle this messy data. So you can use the RE, means the regular expression. So here what we have done, we have created a function called clean string, means clean this state data, right? We are inputting this string here, creating a new result list, right? And we are accessing each value, means Alabama 1 first, and next we are stripping any spaces. So in this case, this, right? Storing the value in the value again. Next, we are checking whether any unwanted escalation hashtag question mark are there, removing those, making sure the first letter, because this is the name of state, first letter is capital, and appending those into the list in this list created and returning that list. So as you can see, the after running this function, the clean state and providing the input of the state string, uh, s- uh, state list, and this, I get the clean output of the state which removed all the unwanted spaces, the exclamation mark, the question mark, and making the first letter of the state capital. Next, let's move to the lambda function. So anonymous, this is also called the anonymous function, which what is mean by the anonymous means you don't have to write the full definition of the function. You can just specify the lambda means the one line function and will do the operation. So here what we have the list, right? List one. We are putting this list and the function and returning this list. And the function which you are using lambda means just multiply by 2. So it is returning 0 to 4 and after this function it return by 2. It's very useful in the data analysis but because you don't have to write a full syntax of the function if you want to do a quick operation. Let's move to the generators. So generators are very important. So what happens? So how the iteration happens in the Python, right? It is happened because of the iteration protocol we have. What do I mean by that? Let's say you want to iterate over list, right? List has 1 to 10 and you are accessing each element of the list one by one. So that happened due to the iteration protocol. And the generator, what happened? It will help us in that. Means it will access the each element one by one, right? So let me create some dictionary where this is the key A 1 2 3 B3 C3 and some dictionary, and we want to access the key means we want to A B C, we want to access those. I can access using this, yeah, correct. Now what you can do, you can also use the iter method with the sum dictionary and it will give the same output in the list A B C. And how the generator will help us. So it is very similar to the function, but instead of return, you use the word yield. Likewise here. So what is happening? It is returning the square. So it's a function called square. It's returning the numbers from 0 to 10 and giving values one by one. So let me run this. Square, I'm putting it to 10 and you can see I'm not getting the output here. It's a generator object square at the location of the memory. Now, if I want to access of the element of the G and G generator, I can run a for loop like this, and it will give one value one by one, 1, 4, 9, 6, 16. These are the values from 1 to 10 and squaring those. You can also use the list the in this case the set comprehension, right? And access those values one by one. Iter tool module, which is again, it's one step further from the generator, means it will have the additional functionality like the group by, which take any sequence and function and return result value of that function. What we mean by that? Let's say we want to return, we want to create return the first word of the name, right? And also we want to group by means if A should be grouped into one, W should be word which start with W should be group one, and the likewise. So if I run this, as you can see, what it does. So this is the function which returns the first letter, and in this one, what we are doing group by. Iter tool from iter tool library group by names. What is names here? Is this list? It take the list, return the first letter and group it, okay, like this. So also I will also like to touch base on the error and the exception handling, how this happens in the Python. Let's say I want to convert one into float. Yes, I can do that, but what happens if I give it a string as the input to the float? Will it work? No, it gave as the value error, means could not convert string to float football. Now we can handle this using the try, means what happens in this block. So try and accept. If try this work, it will return this. If this block of code does not work, it will return this. So let me run this function. So if I run this float converter to 2, means convert this 2 into float, it will give 2.0, correct. Again, if I want to convert this football, in this case I will not get the error but they return the same value, means I have given the x, it did not work, then try, then it goes to 1, return the same value what is in the x. Let me give the another value and this time I want to capture the value error right here. 1, 2. So what happens if if you want to capture the very specific error, not the all, right? If only in the value error, return this. So here what we are trying to give the tuple. So the float argument must be a string or the real number, not a tuple. That's the value type error we are getting. So to full in the error handling, there are other elements also. Or try we have seen, except we have seen else. So else will only run when the try get executed. Means let's say in this we are opening one file, which we'll discuss in a minute. And if file is open, we'll write to the file and print succeed. If you're not able to open the file, then say closed. And the finally is the block which will run no matter what. Means in this case we are closing the file whether we are able to open or not. So let also see the file and operating system, which is very important because we are going to work with the files. So in this case we are providing the path. So text.txt is already there in my local path working. When I say local path, it means my working directory. That's why it is only the relative path I'm giving. And the path value I'm using in the open function and coding UTF, which is very common. And now what will happen, whatever the context was there in the text txt is code stored into the f object. And now I can access the object one by one using the line, using the for loop, right? Print. So it has the lorem ipsum data one by one. As you can see, there are by default the values, some spaces are there at the end. If you want to remove those, you can use the list comprehension. Means again getting the path and encoding means getting the data, access with the value, and each line will then get the R strip, means remove the space from the right hand, and it will store it into the list. And let's close the file. So why we are closing the file? Because if the open, you have to manually do that. Means you have to write the f dot close to close the file. But if you are using the with, it will automatically take care. Means once the file is open and the operation is complete, the with automatically is going to close the file. So open path encoding means store everything, the file data into the F binding, and then remove the R strip and the line. The same thing which we did earlier, same output. You can also write the data to the file, right? We are opening in the mode W means write, F, write some line. So let me add some text. And if I want to read, I'm using in the mode data read now, and I'm reading the file from this temp.txt. So that's how you access the file. That's how you write the data into the file, and that in you can read the data from the file. There are many other functions like read read lines. Readable means if it is readable, it will return true. If it is writable, it will return true or false. So we have covered all the basics of the Python in the two videos. Now we'll jump directly into the NumPy. Thank you. Hi everyone. So in this video, I would like to talk about the NumPy, the numerical Python, one of the most important library available in the Python to do the numerical computation. So how do we import the NumPy? So the standard format is import NumPy, and you can use the alias NP. Though you can use the other name, but NP is the general what most of the programmers they use it. And why we need NumPy, right? We already have a list which you can create a matrix of a list also, but the most important advantage of using NumPy if you are doing numerical computation is how it is very fast. Means the element which are stored in the NumPy is stored in the continuous memory location. That's why its retrieval, the operation on the NumPy is very fast as compared to the list in the uh, list, right? And to show that, so let's do one quick test. So what I'm doing, I'm using the NP arrange to get the 100,000 records, and creating a list to create my list for again the same amount of elements. And let's the time it out. So if I just run this and run this again, so in the case of array, it took around 1.22, and it took 30, right? It's you can see the difference is almost the 30, right? And the loops which are happening is 10,000, and here the loop in the list happening is the 100,000. So you can see the time taken by nanoseconds is way huge compared to almost like 100 times or more than that in this case. That's why we use NumPy for all the arithmetic computation to do the fast operation on the matrix. So NumPy also has a very specific type which is called ND array, which is nothing but a multinational, multi-dim, not multi-dimensional array, right? So it's an object, and how you do that? So you start with np dot array and you put your list type data in it, right? And that's how it will represent in this format. So it's a array. It has two rows and three columns. So it's called 2 into 3 array. You can do the operation on the within the array. So let's say I want to multiply by 10. So it will multiply whatever the element is there. Each element, it's very fast. So I do on the element wise multiply in one go. You can do a summation of array to array, right? You can do that. And if you want to see the shape, so as I told, it's a two rows, three columns. So that's why the shape is 2 comma 3. And what is the data type? As you can see, the format is in float. So the data type here is float 64. How you can create a array from the list? So let's say you have a list called data one, and what you can do, you can use your np means n dot array and put your list inside it, and it will create a array. So it's okay. It is not defined. Let me run this. Let's run this. Now it's done. So that's how you create an array from the list. There are specific type of matrix, like if you want to create all the zeros, all the ones, so you can use np dot zeros with 10 element, right? It will give you a zero with one element, so it will give you all the ones in the array. And if you want to have a array in a specific metric type or shape of into 3 into 6, mean 3 rows and 6 column, you can run this and out it will create. There is a special type np.empty. It is nothing but it will give you all zeros or it will give you the garbage values. So let's run this. So in this case, all these values are the garbage values, and we use np.empty types only when we want to update the values and want to create a structure first. Next is the so a range is nothing but equivalent to a range. So in the list we use a range, right, to get the equi-space numerical elements. And in this case, in the NumPy we have a range, right? And that's has given 0 to 14, that 50 elements in this. So here what I'm doing, I'm just getting those np to range elements, converting into the array, though I don't require it. And data type I'm putting as the float. In this I'm data type putting as the numeric. So as you can see, there is no decimal values after the element. Let's move to the next part, the arithmetic and then with the NumPy array. So you can add, do arithmetic. Let's create the array. You can multiply this array with the same. It has the same shape, right? And you can do the minus. So it will minus within that itself. So again, the value should be 0 because we are minus 1 equals to 0. You can divide by 1 by the value, right? You can do a square, and you can also do the comparison with the same size array. So let's create a one more array, array 2, and give the if the value in the, so what it will do element wise means, uh, so if I just pull the AR, so what it will do, it will compare 1 with 0. So 1 is greater than 0, then it will return true, right? If I run this, it will return true. 2 is greater than 4, no, that's why it returned false. Next is the indexing and slicing, very important. So how do you extract the subset of the element within the array? So let's create an array of 10 elements 0 to 9, right? And in this case, let me get the fifth element. So fifth element is going to give 5. 2 to 5 means 2 to 5, 5 not included, so it should give 2 to 3, right? And let me just update the value of 5 to 8 to 100. Okay, means 5 to 8 to 100. 8 not included, 5, 6, 7 should change to 100, right? Let me run this. It has changed, and you can see this. If I do 1 to 1, it update 1 1. What is interesting here is, even if I create a copy of this particular and update that value, it's going to update in the original array only. But in the case of list, it does not happen. So let's create a list with name L, right? 1 to 10 element, and extract 2 to 3, right? It gave 2 to 3. Now let's update directly. Try to update directly here. It has thrown an error. You can only assign an iterable, not the numeric value as a whole. So let's create a copy of this into L2, and now L2 I want to update second. 0 1 2 means this 200. Can I do that? Yes, I can. But if I just run the L part, the which we have created here, you see it's remained intact, no change in the element. Now let's go to the array part. So let's see the array value here, and let me run it again. So we have the same value, and let me run this 0 to 1. Yep, sorry, 0 to 109. Now let me create a sub array from this 5 to 8. Is this the, it will give 5, 6, 7, and let me update this 5, 6, 7 value means seventh value to 1000. It has updated. But if you again check, the, we have updated only the sub array. We have created a copy also, right? Uh, let's see. So it has updated the seventh value to 100 directly, because even if you create a sub uh, slicing of the existing array, the actual value, it is referring to the actual value. If you don't want to update the actual value, you have to create a copy of it using the dot copy function. Let's create the two-dimensional array. So in this case, np dot array 4 5 6, right? If I run 2 is 0 1 2, so it has done the row wise slicing, so that's why the 7 8 9 is got extracted. So 0 to 2 means 0, this row, and this column 3, right? That's why it has given 3. Even if you put a 0 comma 2 means give me the from the first 0th row, the second uh, means the second from the second column, right? The same. Let's create a 3D array. So 3D array is a 2 by 2 3, right? So it has two separate list or array within the array. Its dimension is 2 multiplied by 2 by 3, and if I put a 0, so means 0 is this one, 1 is this one, right? If I put change it to 1, it will give me 7 8 9 this. And let's create a copy of us of 0 means this into and put into odd values, right? And now update the 0 to 100. So every value from here it's got updated to 100, and you can change the same with by equating with the old values. So old values was nothing was 1 to 6, right? If I do that, it's got changed to whatever the value was there available in the first case. Next is 1 0 means the from the one, this one, right? And 0 means this one. So it's a one step lower level dimension indexing. So what will happen if I run this? So what is its meaning is here, select the first two rows because I have not given anything on the columns. Column is by default all the columns values are coming. Now what will happen in this case? What I'm asking is give me the first two rows, right? First two rows and start column after one. So means this and this 2, 3, 5, 6. And in the case if you write without the columns, it will take that exactly the row means this one, and after 2 means this value. Similarly, this is the same example. So let's move to the Boolean indexing again, the very important part. Instead of returning the element, it just return the true and false. So let's create a two data object, names and data. Names is this, data is this, and let's evaluate. So name equals to Bob. So where it is Bob, it will return true or false, right? Based on that. So first is true means it value is Bob. The fourth value is also Bob. Now learn if you run this name equals to Bob in data, what it means it's passing this particular array here, and if value is true, so in this case this is true and this is true. That's why we are getting 4 comma 7 0 comma 0. What these symbols mean, it negate means give me everything where Bob name is not equal to Bob. So that's why apart from 0 7 and 0 0, every other values are fetching, it's fetched here, right? It can also do the comparison where data is less than 0. So return me those values, right? Minus 5, minus 12, minus 4 are returned here. And if you want to change those values, only those values with the condition. So if data is less than 0, make it 0, right? Earlier it was minus 5, 12, 4 converted to 0. Fancy indexing is also one of type of indexing which is available. So let's create a zeroth 8 by 4 matrix, right? It's 8 rows, 4 columns. And what is I'm doing here, I'm looping here the element one by one and converting into whatever the number. So 0 to 8. So it's first 0, 1, 2, 3, 7 to 7. So the range start from 8, if it is 8, so it's all 0 to 7. And if I do the slicing here, so fourth means the fourth row, third row, zeroth row, sixth row, that's what is retrieving here. And if I do minus sign, it start with the bottom. Transposing and swapping axis, so in the linear algebra, so this is widely used. So let's create a new array of 15 elements with the shape of 3.5 in 3 rows 5 columns. And if we do dot t means it transform whatever rows is converted into columns means it will have 3 columns and 5 rows, right? You can do the dot multiply with the existing value. So np dot dot is the function. You pass the transformation plus the actual array. These another way is doing the at the rate instead of np dot. Thus it's the same result. So let's move to the next part is the pseudo number generation. It uses the baseline Python random module where it then generates the random number. It's actually not random. There is a functionality which is being used at the back end is to generate the random variables. It's not actually the random, so it has some mechanism in the back end which gives you the random value. It looks like it gives the random value. We can control that in short. So let's use that np.random standard normals made from the standard normal size by 4 by 5. Give me the sample, right? And also if you use the random and import the normal variate for n thousand, you see the time taken by these two. The baseline randoms takes more time compared to the numpy's random. So it took 78 millisecond, it took 20 millisecond only. You see the difference is huge. What you can do, you can create your own variables. RNG is not nothing a random generator, right? See the seed. So what happens with the seed? If you use the same thing, you will generate the same values with the seed, right? And same thing we are asking to create the matrix of 2 by 3, array of 2 by 3 from the standard normal uh, values. There are universal function means the first element wise array function. What we'll do with this, you use those function and it will do the element wise operation one by one. So if on the AIR, so if I see what are the values AIR array is this, and why I want to the square root of each value here. So as you can see, the square it always has done the operation of square root on each the values. And next one is the exponential on each element. Let's create a two x and y variables, right, with 8 values. Now, if you want to find out which is the maximum between these two, so this one or this one, which is maximum, 0.4 is the maximum, right? And this, which is maximum, so 0.9 is the maximum one. So that's what the np.maximum function does. It identify, compare the element by from x and y, in this case, two arrays, and give you the maximum values. You can multiply whole x with 100, and np-modf nothing but it will separate the decimal part and the remainder part in the two. So if I do on the x, so x we know this is there, right? So it will separate -1 and this decimal, so see the remainders and see the whole part. So that's what we have in this section. We'll continue, we'll have one more section of the NumPy, and then we'll move to the next part of the this series. Thank you. So continuing our conversation on the NumPy, let's start with the array-oriented programming with arrays, NumPy array, right? And let me load the library. And what I'm doing here is np.arrange is nothing but it will fetch the data with from -5 to 5, means these are the size of the matrix, and it the difference between the point one, all the points, right? So uh, all the arrangement is between these two variables. Now let's do a mesh grid. So mesh grid is take two-dimensional array and produce the pair. So in this I'm just using the both point and putting into x and yx. Right, let me show you that. And now we are calculating the square root. So it is nothing but square root of x square plus y square, right? Z and p dot square root is the function, the inbuilt function which we are using, x's and yx and z. And let's plot this. So to plot anything in the Python, we use matplotlib library. If you don't already have, just use the pip install matplotlib. I already have, so I'm not going to run this. And let's plot this. So what I'm doing, I'm importing the matplotlib library and using the mishow function with the z zeta or whatever we have calculated just now. And color mapping is the gray, right? And it will have the color bar in the title. So let me run this. So this is what the image plot for x square plus y square looks like for all the grid values of all the grid of values, right? Also, let's go to the expressing condition logic as the array operation. So what I mean by let's create three arrays x, y, and condition. So as you can see, the size is same. It has all the five elements, and let's if I want to based on this condition, I want to extract the data from either from x or y. So if it is true, then get this data, else get this. Right? This is what the condition says. If x is true, right, give me the x. If c is true, give me the x, else give me the y. And I'm just dipping these three sequences into one, right? So I got 1.1 because it is true, right? In this it is true, and this is true, else false for this one. Now same thing you can do in in NumPy using np.where. So what happens is check the condition. If it is true, it is goes to x, else it goes to y. Same output with one line of code, and without doing the for loop. So let's get the matrix of 4 by 4 from the standard normal, and we can check with which element is greater than 0. So in this case, this is greater than 0, this is greater than 0, and it will give you the Boolean matrix of true and false where the value is greater than 0. And what you can do, you can also change the values based on this condition. If value is greater than 0, then make it 2, else make it minus 2. It did not change because we are doing the operation on the copy. Right? It's copied the new, created a new matrix. The original one is correct, same. And again, you can use the matrix itself. So if it is greater than 0, make it 2, else make it keep whatever the value is present. Now let's talk about the mathematical and statistical method. So in this, let's create the 5 by 4 matrix, right? And I want to see the mean of this. So in the statistical mean is nothing but it will get mean of full matrix, right? And you can use air dot mean function, or you can use the numpy np dot mean for the same purpose. It will give you the same result. You can get this sum, right? Sum of all these and full matrix. Yeah, or you can use np dot sum passing the matrix in the argument. What is interesting, let's say you want to get the sum of these rows only, right? So rows, it you have to use axis 0, and for column you have to use axis 1. So just pass this additional argument axis 1 if you want to get the summation or mean or any other statistical operation like this. So it is for the columns, it is for the rows. Cumulative product is nothing but what it will do, it will sum, right? Like it will add, keep adding this one, this one, this one, and this one like this. So let me, if it's very just difficult to calculate, means let's create a new matrix, right? 1 to 0 to 8. And if we do the cumulative sum by the axis 0, 0 always mean rows. So it will sum like this, right? 0, 0 plus 3, 3, 3 plus 6 equals to 9. And instead of summation, if you want to do the product, you can use the cum prod, right? And it will 0 multiplied by 3, 0, 0 multiplied by 6, 0, right? So we have a 0, 0, 0 in the first row. Now let's talk about the method for the Boolean array. So we let's create the 100 element array, right? Mm, And we can have, if it is greater than 0, make it sum, right? How many elements are there? 56. Less than 0, 44. There are other two inbuilt functions, any and all. Any means it will check with for if any of the value mismatching your condition. All, it will check whether all the elements are matching your condition, right? So Boolean, let's create this array. So whether if any of this true, it will return true. If all these are true, it will return false because we have a two false here, right? You can use the sorting uh, np. Let's create a 8 element array, right? And you can sort using the sort functionality. Also, you can use the unique. Unique is nothing, it will remove the duplicate like distinct in the SQL or in the base Python we have a set. So if you do a set and the values, it will remove all the duplicate values, right? So if it is unique, so the Bob will Joe, it will not repeat again. Linear algebra, the very vast topic in mathematics and in programming too. But there are many inbuilt functions available already. You don't have to do the calculation, and you can use the inbuilt function of NumPy or base Python to do this. So we'll use the NumPy in this case. So let's create two matrices, right? X and this is Y, and I want to do the dot product of this. So I can use X dot Y, so it will be dot product of two arrays, or you can use NP dot XY, or you can use the at the rate function between these uh, two arrays, and it will result the same output. So s- different way to do the same thing. There is a library uh, inbuilt in the NumPy which called ALG, linear algebra, and we are importing here inverse and quadrant to do the operation on the matrix. Let's create a 5 by 5, and I want to multiply, right? I want to first take the transpose of x and multiply with x, right? And if I want to do the inverse, I use the inv function and it will create the inverse of the matrix. And I can multiply this mat and the inverse, right? I should get 1 and the diagonal. And let me show you the one example of random walk which you might have heard. It nothing but by taking the probability of what is the next step, it will add the new value. So let's take the example of how we can do in the base Python. So I'm importing the random module here. Position starting position is 0, and walk means all it start with 0 and every step will be added here. We are taking 1000 step, and I'm just iterating over this 1000 step. If the rand dot int mean if it is 0, right? Uh, then if it is it will take a value, and if step is equals to 0, else it equals to 1. So 1 or minus 1 will the two values which will be adding into the position, right? And the whatever value we are getting, we are just appending this. So let's run this, and if you plot this, you will see. So value is either going to 0, 1, 1, 1, 1, 1, minus 1, 0, 1 like this. In the NumPy, what you can do, you can use the again the random library in the random function in the library NumPy library, and I'm just setting the seed 1 2 4 5 just to get the random new numbers, and the integer is 0 to 2 and steps is thousand. Let me make it 1000. And if it is a flip of coin, if it is draw, then the value is 1, else value will be minus 1. I'm just doing the cumulative uh, s- sum of all the value which I'm getting here. So next one is just I'm taking the checking the what is the minimum value, what is the maximum value, and plotting the same thing here. So all the 1000 values like this. So if I do again, right, if this change it, see it is changing. Yeah, that's for with this we conclude with the NumPy. Next we'll start looking into the basic of pandas, which is very important. The most of the series will be based on mostly on the pandas, and then we'll also include the NumPy here and there. Thank you.
Hi everyone. So let's start with our discussion on the pandas library. If you already don't have the pandas installed, you can use the pip install panda command to install the pandas. And it's very interesting and heavily used library in the data analysis fields. So pandas are mostly used where you have the data in your tabular format, where the data is available either in the rows and columns, and you can do a lot of operation in your data. You can clean it, you can create your data using series data frames. Data frame is heavily used. Again, it's like a Excel like format. So let's start and import our libraries, and we'll start with the series. What are the series here? Series are nothing but the one-dimensional array you can think about, and the syntax to load or to create the series is PD. PD is nothing but a pandas alias is a short form, and it's mostly everybody use. They import the pandas using import panda as PD, and all the operation where you will see PD that refers to the pandas. To create the series, we use PD dot series, and we provide the list type of values in it. So let's do this. We create our first object, right? And what you see here, these 4, 5, minus 5, 2 are the values, and 0, 1, 2, 3 is nothing but the index. And it's also gives us the what is the data type. It's an integer 64-bit, right? And these all the values you can extract separately. Like if you want to see what are the index of this series, what you can do, you can call that method, that attribute using the obj dot index, and it will give you what 0 to 1 to 3 means how it is going started. Start with 0, stop at 4, right? Like the range function, the list similarly to that, and step is 1, so it's skipping 1, right? It's incrementing by the 1 value. And how do you see the values here? You can use the obj array. So it will give you the pandas array in 4, 5, minus 5, 2. Its length is what? 4, and data type is nothing but 64, right? And in this case, if you realize we have not given the index value, it was automatically populated by the pandas. But if you want to call it A, B, C, D, something like that, you can definitely do that. And this, in this example, what we are doing, we are creating a new object, object 2, where we are passing the list in these, converting into series with the user base index when ABCD will be available instead of 0, 1, 2, 3, 4. And you can see that your index is nothing but ABCD, right? Whatever we passed here. And what we can do using those index, we can call the value, right? If you the obj2, what it give? 4, right? Because a equals to 4. And what what I'm doing here is I'm calling this d value, and I'm updating with 6. So you can see the value of d, which supposed earlier the value was 2, now it's been updated to 6. Next, with the index, we can do a lot of operation. In this case, we are selecting the values b and c. So it is nothing but we are combining give us two values from the obj2 series. You can also do the boolean like operation, give where obj equals to 0, it will compare the values, each value with 0. So 0 is this 4 is greater than 0, true. Minus 5 is greater than 0, false, like that. And the here the d type is boolean. We can multiply it by 2. So in this case, all the values, whatever is available is just updating with multiply by 2. You can do the exponential from NP from NumPy. We are doing the exponential of all the values, and it's what it returned, and the data by type has been updated to float 64. You can also check whether B is available in object 2. In this case, yes, true, it is available. So in operation is nothing but it will uh, iterate over the series and give you the true and false whether the value is available or not. Let's make the series from the dictionary. So we'll create one dictionary where we are giving the key or Ohio, and this is the value. These are nothing but population data. And what we'll do, we will pass this into pd.series function and give the value as the s data, and that will make the object 3. So this is again the series. So as you can see, the all the key values have been changed to index, and these are the values of the series, right? And you can convert your object back to the dictionary also using the dot to dictionary. So now it's converted back to the dictionary in the same format. Let's create the state list, and what we can do, we will pass this as data, the dictionary here in this series, and states is nothing but the index. So what instead of uh, what we are doing, we are passing this to Ohio, and it will check with the OBG4. So as you can see in the S data, right, there is no California, right? But we are passing in the index. So if value is not available, it will it will result in NAI, not a number, nothing but the null values. And if value is available, it will just pass and check that value and record it here. So these null values, you will see lot of null values NaN in your data. And there is a function called isNA, right, to check whether the value is null. It is null, it will return true, else it will return false. And this is the pandas function. There's you can directly on the object check whether the is NA. And let me change it to 4 to return the same values, right? Same, two different of way of checking the is NA values. So these are the object 3 and object 4. And what we can do a summation. So what it will do, it will check for Ohio, and sum it. If value is not available, in this case, California is now not available, it will return into NaN. Very interestingly, the we can in this case, you see there is no metadata available. Means we don't know what is this, what is this. We can change that. We can make the add the name of this object population and index name as state. And you can see now this represent the states, right? And also its name has been updated to population. We can see what kind of a data set is. If somebody wants the answer, they can definitely see with this information that is the data set of the population in the following state, and these are the values. Now let's move to the next part of data frame. Very important is like a tabular format data structure where data is available in the rows and columns. And in this series, there was like one dimensional, but this data frame can be multi-dimensional, and mostly it is 2D where rows and columns are available. So let's create a dictionary first, right? So in this dictionary, we have a state, year, and populations, right? And it's the same length. So what I'm doing, I'm just converting, giving that value data into the data frame. So as you can see, it's a tabular format. All the key values has been converted into the columns, and these has been populated automatically. And these are the values. So if you want to see the first five, you can always use head. If you want to see the last five values, you can use frame dot tail. Here, what we are doing, we are telling the pandas what columns to be created in which order, right? Year, state, and population first instead of the state. So you can change the columns here and there very easily in the pandas. So let's create the second frame. So in this, what I'm passing the data and the columns. You see the depth. I'm adding a depth column here, but in the data we don't have depth. So what Panda will do, it will create a new column, but it will complete it with NaNs. So no values are available for this, but still it will create the column. How you can select the separate column? So you can use the frame and the square brackets and the name of the column. Also, you can use the dot format in the same dot for, like frame dot, and it will give you the values like if you put a dot, and it will give you the state, right? Same values. There are other another two ways you can extract the .loc and .iloc. What is the difference? LOC always worked with the labels, and .iloc always work with the integer values. So I will show you what is mean by that. So in this case, what we are saying, give me the second value. Second value in the in is what? Uh, so we have Ohio, right, in the second value, and the year is 2, correct? And also, what I will explain this LOC and IOC in coming video. I have a separate code written for that. Also, if in the depth you can see there's any values, right? So you can update in one go. Like if you put it depth equals to 22, it will update for all the values, all the rows for this column as 22. You can do whatever you want, right? Whatever value you want, 1000. Also, if you want to update with the separate, in this case, what I'm doing NumPy arrange so 0 to 5, it will update 0 to 5 values here. And let's check few things. So I'm creating this again one series with this index, and I'm passing those values into the depth. And why it has not updated anything, though we have passed the uh, values, right? 2, 3, 4. Why it has not updated? Because it checks the index of both, right? It has index 0 to 5, it has 2, 4, 5 in string format. And that's why if it is not, the value is not compared and equals to the same thing, it is going to update with an. So in this, what I'm trying to do is here is if state is Ohio, means when where the Ohio is, it is true, make it true and update it in the new column called Eastern. If it is not Ohio, it will update to false, right? Like this. So if you just extract this, if state is nothing but this part, and if it is Ohio, so it will just do a binary, sorry, Boolean comparison and give you the true false. You see the data type is nothing but Boolean. You can delete the columns with the del keywords. Del keywords, your data frame, your column, and it just deleted the you see the eastern column from here. Let's check the nested dictionary. So in this, what we have a key, and it has a sub dictionary in it. So let me run this. So it has Ohio 2000 this value, 1 this value, 2 value, 2 0. So as you can see, there is no 2000 value in the Nevada. And let's convert into the frame, and Nevada don't have the 2 value. What it did, it took the Ohio and the Nevada and created a column, right? And it took the internal keys and created the index. You can transform this with T, your data frame dot T, like in we did in the NumPy, and it converted your rows into columns and columns into the rows. You can also name your attributes in the data frame like we did in the series frame 3 dot index dot it will index will be called years and the column will call the states like this. Column will be called state and index is called the years. And you can convert into the NumPy easily. Index object. So here we are creating the one series, and the index is what ABC. We are checking what is the index here, and with this index you can do certain operations. So give me the index 1, start with 1, right? Means 0 1 2, so it will give you the 1 and 2, right? Index are immutable, so what let's say I we can see what the values are there with the index, but if you want to update the index, it is not possible. It will throw an error. Index does not support mutable operations. So let's create a label. So I'm just creating a numpy 0 1 2 values, all right, and keeping into the labels. And what I'm doing the creating a series here 1 4 and using those labels, so 0 1 2. So it will give 0 1 2 here and 1 4 2 in the in this column. If you want to check the columns only, so you can use the dot columns, right? And if in operator we have seen in the series, also like in likewise in the data frame, you can use in operation to check whether value is available or not, right? Ohio is available, yes, true. Whether 2 2 3, no. 2 2 0 0 1, true, right? Reindexing, very important. So in this reindexing, what we do, we are creating the index, but let's create one object. So it is DBA, these are the index, these are the values. And what we do, we want to reindex it. We want to create a new index for this, right? Let's do that. A, B, C, D, right? And what happened? We have added a new index, but the value is not there. That's why it is filled with NaN. There is a few methods are available. Ffill, which means it will do the forward fill. There is one more backfill. It will do from the bottom up, fill the values. What I mean by fill the value, let's create one series which has the value blue, purple, yellow, and the index is 0, 2, 4. Let's say we want to make it continuous like 0, 1, 2, 3, 4, and we want to fill those values with some data, right? And in this case, we are using the methods, the forward fill. So whatever is there before value, it will just update it. So like in this case, we have added 1, right? And 1 was filled by blue. Then purple, 3 was filled by purple, and 5 was filled by yellow. So let's create a one data frame. It has 9 values reshaped into the 3 right? And the index are ABC, the columns are Ohio, Texas, California. And in this, let's reindex. So we want to add A, B here, C, D, and E. So we don't have any values for B and E. That's why it's created the NaN like in the series, right? And we want to add a one more column NY, right? New York. So it will again, the values are not there. It will update with nans. You can use .loc which works with the label. So in this, I'm extracting what is mean by this. Give me this row A and C and only the Texas. A and C only for the Texas. You can change to NY. It will only update for NY, right? You can drop the accessories using the let's first fill the NAs here 10, right? Where the Ohio is there. Give me the Ohio, right? And if NA is there, then fill with 10. So here this value is updated to 10, this value is updated to 10. And you can drop the values using the drop function. Provide the provide the index, and as you can see, the C is being dropped. If you want to drop multiple, so you can let me just run it again, and you can give a list of which index you want to drop in in this case C and D. Let's create the data frames one, and let's drop, you can also drop the full column, like in this case sorry, full index. In this case Ohio will drop the Ohio, and in the next we'll drop the columns 2, right? 2 is not available now. Next is what indexing, selection, and filtering. So let's create a one series where in the index is ABCD and start with 0 to 3. It's a float type because the dot is there. And if I remove dot, it will become int 2. Right, let's keep it float only. And I want to get this value, right? So what I will do, I will just keep it B. It will give me 1, 1, 2, 3. So it will give me two values, right? 3, 2, minus 1. Start with uh, 1, 0, 1, 2, and 3 is not included, so it's excluded. If you want to have, you can create a list within the object and it will give you the B and D, right? Index. You can also use 1 and 2. It will give you very similar what we did here, right? And also you can use, as I told, LOC always work with the label. So if you can use A and B, it will give you the A and B. On the other hand, the ILOC works on the integer type. So it will create an integer value 0, 1, 2, 3, 4. Like in this case, what we are asking give me 1 and 3, means it will 0, 1 means B and 2 means C. 3 is not included, that's why D is not available. So let's create two object 1, right? 201, object 2, and let extract the from object 1, 120. So it will give you in that same order 120. In the object 2, again, uh, same thing. So as you can see, the object 2 has the index in this string ABC, but still we are passing the values 1 and 2. It is giving like 0, 1, and 2. 0 represent A, and one represent B and two represent C. So in the same order, it is giving back the result. Same, if you try to do the LOC 4012, why it is failing? So it is giving the index because none of the index data types are in the index. So we are trying to extract values in 012, and that's why it is failing using the LOC because it works, as I told, it works in the label. Okay. On the other hand, if we try to do IOC, it will work because we are using the integer type in the ILOC. That's why it is working. So just understand, if you use .loc, you are working with the labels. If you working with ILOC, it is working in the integer type values into the index. So it is giving B and C, right? Working. Data one, we have this, and if you want to extract the column, you can use this square bracket column name or data frame dot column name, what will work. Right? If you want to extract two columns at the same time, you can create a list inside it, right? One, two, three. What is being one, two, three here represent? So it represent the index, right? Colorado is one and Taha is second. Here we are doing the binary comparison in the data vine three in third column, right? Here, if value is greater than five, return that, right? It is returning all the values which are greater than five in three column. And you can check all the full data set in data frame. If it is less than five, it return true, else it will return false. You can use LOC on the columns also if give me the all the values in the New York, right? And IOC2 represent nothing but the index. Again, same thing, 2 and 1. It is giving in the different order because we are asking Otaha first. As you can see, Otaha is second and Colorado is above, but we are asking 2 and 1. That's why the order is written like this. So what will happen in this one if you run this? What we are trying to do here is our in our data frame dot .loc, we're asking if 3 is equals to 6 updated with 5. What is this is wrong. It's going to throw an error because what Python is saying, a value is trying to be set on a copy of a slice from a data frame. Try using dot row index, row indexer, and column indexer. So what is a row indexer here? This is we are trying to extract raw, and we need to pass the column like in this in the next, and that will update to 5. So the what is we are if the value is 6, right? Colorado is the value of 6. Now we have updated to 5. So that's how we used indexes with the LOC and dot ILOC in both series and data frame. Series and data frame are highly used objects data structure in the Python. We'll continue our pandas. I will create one more video on the pandas. Um, Thank you for now. Hi all, welcome to the second part of the pandas tutorial. So in this, we'll continue our discussion on the pandas. So let me first load both NumPy and Panda library. And what we are going to do, we are going to look at the arithmetic and the alignments part of in the pandas. So first we are going to create two series. So in this were these the four element series and the index we are providing A, B, A, C, D, E. Second one is again the second series where there are five uh, indexes, right? We are getting five. So this S1 is the first series, A, C, D, E, and S2 is the second series with the five element. So if we do the addition of these S1 plus S2, what's going to happen? So when we do the addition, it's going to look at the index. So in this case, A from S1 series, and if it's index for S2, and if they match, then it's going to perform the addition. And if the value is not available, and if you try to add, let's say 3 plus NaN, value is not available, then the result will be Na. So in this case, the A is available, right? C is available, D is available. D is not available, that's why it's so why? You will think about D is available here, but D is not available. So it should give 3.4 values. No. So if you try to add, like in this case, so just a second. Yeah. So think about like that. If you are adding 3 plus an value, right? It's going to throw an error, right? NA is not defined, or let me just write the np dot nn. The result is nan only, right? So in this case, 3.4 plus nan is result in the nan. That's why the D is nan, and likewise the other index value is also nan. Let's do the same thing with the data frames. So let's create two data frames here. DF1 is the one where the index is what? Ohio, Texas, Colorado, and the D2 we have the Utah, Ohio, Texas, Oregon, right? Now again we are trying to add these two data frames. So B from Ohio, the value is 3, else all the values, most of the values is nan, because the same reason. If we try to do the 3 plus NaN, the result is NaN. And NaN plus NaN is also NaN, right? Let's redefine our df1, df2 again. And in this case, if you want to extract, right, let's change one value here. So in the df2 b column, the first value 0, 1, 6 will update with an n, right? And now we again try to do the addition. So same thing. It's if the value is both the values are available with this with respect to the index, then it will update, it will add, else it will return an n, not a number. You can use the add function of the data frame itself, data frame dot add, and fill the values with 0 or something if required, and then the operation you will result in the actual value. So if it will be 3 plus 0, then the value will be 3. You can do the division 1 by divide, right? And it also has the data frame also has the same value. One function r div which do the same operation, same values. Let's also see the operation between the data frame and the series. You can think about like the matrix and 2D matrix and 1D matrix, right? Let's create a array of 3 by 4, right? And let's divide this array with the first uh, rows. So this will result all zeros in the first row, right? All zeros in the first rows. Let's create a data frame. All right, we have the column BDE, and these are the indexes and these are the values, right? And let's create a series out of this. So what it did, it asked for the first Otaha, right? And it created the series out of it. And if we do the subtraction from the frame minus series, it will result in the first row zeros, right? All zeros. Let's create the second series. Here we are using the arrange 0 2, it will result 0 1 2, and the index is BDE, sorry, BEF. And if we try to do the summation of frame plus series, again the same thing. If the value is available with respect to the index and the column, it will result in the addition, else it will result in NaN. Let's check some of the functions, application, and the mapping. So in this case, we have creating one data frame. We are choosing data in this case from the standard normals values. The matrix is 4 by 3, right? 4 rows, 3 columns. And we can do the operation like the absolute, find the absolute. So there are some negative value, it will generate into the positive values, right? The minus 2 becomes 2. Apply method and apply is very important, mostly used. What it does, it's apply if there is a function available and you want to apply all these function to your data frame or the series, it will apply that like this. So we created the function f where what it returning, it returns the maximum and minus the minimum value. And what we are doing here on this frame, we are applying this function in this function across the axis, right? And it will return across all the columns. Next is we are uh, returning the series instead of one values, right? And same thing in the min and max are the indexes we created for B is this is the minimum, this is the maximum value. Next one we are formatting. We are asking to change the format of the element in the data frame to two decimals, right? Same thing in this case we are using apply map method. Sorting and ranking, very important. So in the sorting and ranking is what? So if there are values in the series or the data frame, you want to sort it using the index or using the value. There are two main functions are available. Sort index will sort based on the index, right? In this index, it is not sorted. So if you use this, it will become sorted. If you want to sort based on the values, this part, then you can use sort values. Similarly for the data frame, so this is a data frame we have and we want to sort based out of the index. So one will become first and then three. And the values you have to provide using which column you want to sort it. Like in the Excel, it's the same thing you provide uh, sort based out, select the column and then sort it. Same thing here. So based or B sorted, you can also change it to ascending false and it will now sort based on the descending. Next one is for rank. So rank function, it will give you the equal value or assign a rank that is the average of the rank of those values. So if this is a series and want to enter rank, so it will assign the average value of this complete series to the particular index. X is with the duplicate label. So whatever we have seen till now in the data frames and the series, we have the unique axis, right? But that is not the case in the actual data. You will get duplicate values in your axis and what how to deal with that. So in this case we'll use the unique method which will give you the unique values in your index. So let's create the series with duplicate index. So in this case A, B, B, C, these are the duplicate index. And if you extract the A, give the A, so it will give you the full two values, right? And if you want to check whether it is unique, so it will give false because these values are not unique values. Similarly for the data frame, right? If we have B, and CC, and if you extract using A, it will give you the two values. So let's also see some of the descriptive statistics available function which are available in for series and data frames. So let's create one data frame, right? It has two columns, one and two, and these indexes are A, B, C, D. If you want to make a sum, right? I want to make a sum out of it, and then we can use the data frame function dot sum. So what does the summation? It will do the summation of the column wise, right? For A and 2. Now you might be thinking, why? How can the value is not available in A and it's still giving you the sum of that? In so what happens? It in by default, it is keeping the NAs, and if you don't want to skip the NAs, you can use skip NA equals to false, right? And in this case, because the NAs are available, it will return NN because you cannot do the addition with with the unknown value, right? X is one represent to do the summation of the row wise, right? And mean again, mean is nothing but to give you the average values for A full A and B like this. If for mean actually there is a one, if one value is available, that is fine too. It don't have required like it required one value to be available. If both the values are NA, then it will return in the NA. Like in this case, both the values are NA, it returned NaN. If you want to do the column wise, again the same thing. Axis one and column both represent same thing. That's why the results are same. IDX function is nothing but it will check the indices and give you the maximum values where it is located. So in this case, on the one column and B index, the maximum value is available. You can check 1 and B 7. Minimum is nothing but it will give you the minimum value and describe, very important. It will just summarize, give you the different statistics in your data, like how many values are there, what is the mean of there, what is standard deviation, what are the minimum values. 25 per quantile, right? And median values 75 are the maximum values. Or similarly on this series, if what is the unique here? So in the data frame we have all the numerical values, so it described differently. But in if your data is available in the non-integers values, so it will give you a different description. Like in this, the total count is 16, unique values 3, top values a, frequency is 8. Next is the unique values, the value count and the membership. So unique value is nothing but, as I told, there can be the scenarios in the index or in your actual value if you want to identify, like in the case of set data structure which you give with routine unique values. Similarly, if you create a series with duplicate values, you can find out the what are the unique values using a unique function. And if you want to get the counts, so it will give you how many times C is available, A is available, and you can also sort it, right. You can sort index or sort value, right. In the case of data frame, it's a different thing because let's say for q1, right, this column you want to do the count and sort index, so it will give you. But if you do on the complete data frame, it will give you tuple. So in this case, this is the data frame, right? It has a uh, duplicate values like 1 1 1 1 1, and you want to save the value count of it. So what happens here, so it it has taken the tuple, so 1 0 1 0. So this is two times, right? That's why it is 1 0 1 0, two times 2 0 2 0 two times, and 1 1 is one time. So that's what the value counts on the dictionary. So that's what we are ending the very basic details on the pandas, and we'll move to the in the next section. We'll see how to load the files and start doing more on the data analysis part while loading the data, how to load the data, different type of data into the Python, and how to start doing the data analysis. So we have covered the basics of Python, NumPy, and Pandas till now. Thanks. Hi everyone. So now we have some understanding of the NumPy library, the basic of Python in the Pandas. We'll start with our data analysis part, and the first step of any data analysis exercise, you have to load the data into the memory into the Python to do any data analysis, right? So in this video, we are going to see how we can load the data into the Python. What are the various ways? I will try to cover as much as possible. So let's start. So we'll first start importing our main important libraries, the NumPys as NP and the Pandas as PD. Next, we are trying to load the CSV file. So CSV files stand for comma separated vectors, which in the file everything is separated by the commas. And to do that, there is a function, inbuilt function in the pandas, PD is pandas dot read CSV. This is already there in my local. That's why the path is this file. But if the file is available in different directory or in different location, then you have to put the full path. So let's first read the file. So what we have here, we have the five columns and three rows, right? And as you can see in the file, I have not in the parameters, I have not mentioned what to do with the header, right? Header is something which is the top of the first row. So in this case, the Python has automatically detected like ABCD is the header, 0, 1, 2, the index is auto-generated, and the value was assigned against the each header which was there in the file. Now let's say there is no file, no headers available, and this is example 2 file. So in this case, the header is none. So let me try to remove this for a second and run this. So what happened here? The first row, and again the Python do it, it automatically assume if you are not providing the arguments that the first row itself is the header, right? And if we tell the Python like this is the first header, the first row is not the header is none, header is not available, then the Python automatically again generates the header like 0 to 4, and index again it's auto generated and it will show the result like this. What you can also do, you can assign your names. Name is nothing but the columns as what you want, right? A, B, C, D, and the messages. And in this case, I'm using the example 2 again, which does not include the header. I'm explicitly trying to convey to the Python, please add A, B, C, D message as the new headers. Let's move these headers into the names variable. And in this case, what I'm doing, I'm just doing the same thing here, adding the names. And additionally, I'm telling Python the index column will be the message. So don't auto generate the index, use the message as the index. So let's see. So what it did, the message, the index has been created, right? And these are all the previous columns. What if there is the hierarchical index? Hierarchical index means you have a first level and there is a second level. So let's see what is the example of this. So in this, what I'm trying to say to Python, the index column, make the index key 1 and key 2 as a combination. So if you are aware of the, in the SQL, we have a composite key, right? You make combine these two can make a primary key. So very similar to in the hierarchical index, make the index 1 and so let me show you what uh, this looks like without this operation, right? So we can write pd read csv and the example 3, right? So in this case, we have a key 1, key 2, and value 1, value 2 as the column. And what I'm trying to say, to pandas, make this key 1 and key 2 as the index, right? So as you can see, is 1 grouped into one index, then it has sub index A, B, C, D. Again, 2 has the second index and again grouped to A to D. So we can also read the txt file. And let's say if there is a txt file and it is separated by the spaces, means instead of comma there are spaces, you can provide the additional argument called scp separated by slash space plus, right, like this, and your values will be again read, it can be read by the pandas. What happened there is in most of the files there are some headers or some string, just to give you the detail what this data set is going to do, what is data set is all about. So if you want to skip those rows, you can do that using this skip rows. You can definitely tell pandas don't read 0, 2, and 3 rows, and you can read the others. What happens if there is NAs in the data? And this will be the most of the cases if when you read the data in the example 6 CSV file. So as you can see, this cell and this cell there is NAs. But here's the trick, whether these two are NAs or not. So in this case, yeah, true. This value is NA, this value is NA, but there is a catch here. This value is absent, and the absent value is again it been treated as the NA. There are few options whether you which you can use, like NA values keep it null, right? So in this case, again we have added NAs and null, and default values if you are making it false means if something is does not exist, keep it as it is, right? So make the NAs as NA, right? But if it does not exist, don't make it NA, right? Keep as the value not available, kind of like blank. So if I try to again run the isNA function on this, as you can see, instead the value is not available, though it is saying false, means it's treated the blank as not a NA. There are let's say there's a big file, millions of rows, and you want to see the few rows, if you want to load first few rows, you can use n rows and provide the how many rows you want to see. And also if let's say the file is really big and you want to process that file in chunks, there is a parameter available, argument chunk size, means it will read the files in chunks of 100, and you can perform operation on that. So in this case, what I'm doing, I'm just calculating the keys, what are the keys available and what the value count, putting those into the series. So looping on these chunkers, chunker is nothing but the chunk size of 100, right? And getting the chunky this column, doing the value count and filling the value to 0 if it not available, right? And putting into total, and total I am just appending to this, right? I'm adding whatever coming and adding to the total and sorting that value. So let's see what is the because I've sorted in the descending order, the E has been the biggest, like it has the count highest count, followed by X, L, O, Q, M, J. We can also write back to the files. So in this case, let's say you have you want to export data into the CSV. What you can do, you can let's first read this data, right? And you want to export this out as a different file. So you can use a to underscore CSV function to export the data into the CSV, right? And let's say if you want to see what the value is being exported, you can use sys.sys std out. It will show you in the terminal like what are the values being exporting. For this is separator just to make sure we are instead of we can use anything, right? Double separator also. Oh, yeah, let's do. And the next one is the yeah. So what I was trying to show previously is if there is a NA, how do you want to deal with that? How if you want to export to the NA, you can use some values here, right? Like XX, that will be updated by access. Also, uh, there is a CSV library available. You can open the file as an F and it will read the files into the CSV reader is used to read the files in the lines. And whatever I'm to do, the first column will be the header and all the remaining will be the values, right? The header is 1, values is 2. And you can also convert this into the dictionary using the dictionary comprehension in case we are doing the for loop on KV. We are zipping the header. Header is nothing but ABC and the values. It is creating the tuple of same combination 1, 1, 2, 2, 2, 3, and that's what the keys will be stored in the keys and the values will be stored in this tuple. JSON data, very important. It is the one of the standard way of importing or exporting data or using the data into the HTTP applications, right? And it looks like something like this, very similar to dictionary, right? So the object trying to create an object, the JSON data. This is the name, the city, live, pet, sibling names, right? And as you can see, the each name here, all the keys here are the string in the JSON format. So that's the one differentiate between the dictionary. And to load the JSON data into the Python, you have to use the JSON library. You can import it, and JSON.load is used to load the data, and if you want to export, JSON.dump is used to export data. So we are just putting that object obj object here and getting the result, right? Looks very similar to the dictionary, correct? Now we are trying to convert back to JSON. So you can use JSON.dump result and it being converted to the same what was earlier. Next is if you want to you can convert this into the data frame by passing it. So in this case, I'm just passing on the sibling string. So from result, sibling this one, and only getting the names and age, right? You can if you just put like result sibling, you can put like this. Also, there's pandas also have read JSON function, so you can just read the data directly using the pandas as well if you don't want to use the JSON.loads, right? XML and HTML. So XML is the another very heavily used format to transfer data. If you don't already have, please try to install this XML beautiful SOAP and HTML5 libraries. I've already done that. Now to read the HTML. So let's say you have a HTML bank.html which is contains the all the failures happened. It is some data set available. You can get into the from the site from the internet. So I read using the pandas.read HTML in the tables and it has one variable only, right? And let's put that the first in the failure. And if you want to see what sinks include, so these are the bank, these are city, state, certificate, acquiring bank, closing date, updating date. And if you want to see whole data set, this is 547 rows and the 7 columns. And let's try to convert this closing date into the date time, right? So what I'm doing here is using the toDate function from pandas, getting this failure closing date column, right, and assigning it to the close timestamp. And in the next line, I'm just trying to, in the close timestamp, give me the date, only the year, and do the value count. For each year, it's going to do the value count. So what are the values available for in 2016? Just count it, right? So this is it. 2016 has the 5 values. If you want to work with the XML, you can use the ILXML library. And the same thing, there's one dataset available on the XML, and the past is just name. Past means loading the data only. We are using the Objectify method to pass these to load this data, and this is what the data looks like. So what we have done, we are converting into the list, which includes the dictionary, and you can see how the data looks like. It's a one data set with multiple columns. Similarly, you can use MS Excel to load the data. If you have data in the MS Excel, you can use, you need to install the Open PyExcel library, and you can use the pandas.excel file to get the data. So there are three sheets available if you want to load the data. XML.parse sheet name, and this is the data set available. And you can also use pd.reXML, and it's give the same result set because we are using the same file, right? APIs. APIs is a vast topic, and I will just cover the very basic here. So how you can get the data. If some application they have the APIs. APIs are nothing but the application programming interface. Means if some application they offer the API, they allow you to read the data, right? Get the data and put the data in their website. You can do that. So Python has a lot of functionality over it. So you can use the request library. You can pip install a request, and to get the URL. So we what we are doing, we are getting the all the pandas issues, like top 30 last top 30 issues from the pandas repository from the GitHub, and putting that URL and using the request dot get URLs. This is okay. This is the response, right? And if response is 200, right? So this means it's okay. We got the data, and it's most of the data in the transaction between over the web is JSON or XML. We are putting converting into JSON. So this is what the data looks like. It has 30 different dictionaries, right? Let's extract the first one, the first title. You can extract the first data. This is what the first data looks like. And these you can see these are the keys, and these are the values here. Comment, event, IDs, right? So we were extracting we want to see what the title looks like. So this is the title. And you can convert this into the data frame by passing directly the data into the PD data frame. Actually, these are the issues, top 30 issues in the pandas library. You can also load data directly from the database to do the analysis. Like for this, do you have to use the SQLite, right? That is one way. There is other libraries also. What we are doing, we are first creating one test table, right? And creating the 4 columns here, checking the connection, executing that query. Okay, let's make test one because test is already there, right? And execute the query and committing it. So let's put some data, right? And insert into test one now, values, executing this statement. So insert into test one values. These are the values for values, right? Committing. And if you try to read the data, you can use cursor, don't execute. Fetch all is the function which will execute, which will get you all the rows. So these are again all the rows, whatever we imported, right? You can also check the description. Description, nothing. If there are metadata of about this particular cursor, it will be available here. In this case, only the ABCD is available, and you can put that into the columns name. So these are the columns, and we are converting, putting those rows into the data frame. So that's how you you can connect with the database. So the idea here is how to load the data from different file types into the Python, right? We have seen using the CSVs. We have also seen how to load the data from text format, the JSON files, right? The XML and HTMLs, the read from the MS Excel, how to load the data from APIs, use the request library, right? And also how to load the data from the databases. So in the next video, we'll start getting importing data and seeing how to handle the data integrity, if there is how to handle the messy data, the unknown values or missing values. Thank you. Hi everyone. So in this video, we'll be discussing regarding the next step after you load the data. The first step in any data analysis, we do the data cleaning and the preparation for the data analysis. Like we have the data now. Data is not always perfect. There are many issues with the data. There are the some of the data is missing. Data is in correct format, right? There are some missing values, how to fill those values. There are some outliers, how to handle those, how to first identify the outliers. So we'll be discussing our data cleaning and preparation in the two videos. So this is the part one. So let's first go ahead and we are going to load our libraries in this import pandas np and import pandas pd and numpy as np. So let's first handle the missing data. So what do we mean by missing data? Let's first create this series. So in this series we have five elements, right? And one is np.nan, means the value is not available. How to check if you have, let's say, some series, how to check whether the value is all the values are available or there are some nan included. So you can use is na, right? It will give you boolean series as the output, where false represent the it's not an NA and true represent this value is the NA. Let's create another series where we have included the none, null in the braces and NA in the brace. So here n null represent the value. It's not the actual null or the NA, right? And the np.nan and the none represent the actual missing value. So how to identify those? Again, we use the is NA function. So as you can see, in the case of 3, it's true. In the case of 5 is true, but in the case of 6 and 7, it's false because these are the actual values. It can be anything like null 1, so it's same thing. How do we filter out the missing values, right? So in this, before we do that, you can drop the values. You can drop the NA values using the drop NA function. So in this float NA series, I just include the drop NA, and as you can see, the values which are true in the previous one are dropped, right? And not NA is the negation of the is NA, so it will do the same thing. Uh, it will give you the extract of the values which are not NA. So this all the example were on the series. What about the data frames? So in the data frame, let's create a data frame of 4 rows and 3 columns, right? And if we do the drop data drop NA, what will happen? So it, as you can see, it dropped if any NA value is available any of the row, whether it is one or more than one, it just dropped that particular row, right? You can see only the first zero index one remains, other have been dropped. So how to include the values which have the NA? So you can use the how. What will do if all are the NAs, then only it's going to drop, else it will keep the. So in this case, the index value 2 has all the NAs function, but the others are uh, others have one or more values as available. That's why the value remain. So in the drop NA, you can use the argument how equals to all. Next one is, let's create a data frame with the standard normal value from which has 7 rows and 3 columns, right? And let's create some NAs here. So what I'm doing here, till value 4, and in the column 1 make it NA, till value 2 in the column 3 make it NA, right? 4, 2, done. Now let's drop the NA. So what will happen in this case? We'll only get 4, 5, 6 because drop NA, if one NA is there, it just drop the full row. And we can also include the thresh, which is threshold of if it has two NAs, then only you drop it. Else keep it. Like in this case, 1, 0 and 1 has the two NAs. So threshold if it is meeting equals to 2, then it will drop. Else will just, if it is less than 2, it is keeping the NAs values intact. Now we know how to identify the NAs and how to drop the NAs. What about if we want to fill the data, filling the missing value? So again, let's go to our data frame DF, and I want to fill NA with 100. So in the case of all the NAs here, all the values will be 100. So you can put any value, so 1000. So all this will be updated with the values. Again, you can also pass a dictionary. So in this case, for column 1, it will update 0 0.5. For column 2, it will update with 6. Column up 1, it update with 0 0.5. Column 2, it updated with 6. Let's move to the next, create one more data frame of 6 by 3, right? And again, instead of doing the NAs in the top, let's do it the bottom, right? Start from 2. So this means start from 2 to till the end. In the column 1, start with 2 till the end with column 2. So we have the NAs. So we have also discussed these methods. This means forward filling, and this there is one more called backward filling. So what it does, if there are missing value and want to fill the previous value, you can use fill any method equals. So what the value is available here, it will just cascade it to the in this missing NA in this column. Similarly, this value will be filled. So as you can see, 0.2, it got cascaded to the end. It's got. So let's say you don't want to cascade to the till full all the rows in the column. What you can do, you can set a limit. Only two values will be filled. So in this case, there were two values filled, two values filled, two values remains. You can also take a mean. So mean is nothing. So df dot mean. So it just calculate the mean of these values, right? And whatever value is come, it just fill. If you are doing fill any with the mean, it will fill with the mean. Next is data transformation. So let's uh, how to remove the duplicate. So duplicate, you will get a lot of duplicate in your data. Mostly in most of the cases, there are some duplicate entries in your data observations. So let's create a data frame from the dictionary. So we have k1 and k2 are the two columns, and this is 1 2 multiplied by 3. So 7 entries, right? And again, this has the 7 entries. Now if this is our data, and we know this is a duplicate values are there, so which one is the duplicate value? This one is not a duplicate value because these are two. Consider this as a tuple, right? 5 6 is a duplicate value. So if I do that and identify data to duplicate, so this one is the duplicate, means the duplicate of the previous value which is available in the in this data frame. And you can use drop down duplicates. So in this case, the sixth row will be deleted. Index value 6. Let's add one more column v1. We are passing the range. It will give 0 to 6 values, and we can drop the duplicates considering one of the values. So in this case, if considering the subset k1, drop the duplicates. So what happened here? So it consider the only subset for k1, right? And as we can see in the k1, it's 1 2 1 2 1 2 1 2. So only the first value will remain, others are duplicate because we are giving a subset. You can keep a two subset, like in this it will take us this tuple and then compare with the other values, right? Transforming data using the function or mapping. So let's create a data frame. So we have a food beacon, right? And the next was the ounces, and this is the data we created from the dictionary in a data frame format. And this is again one of the dictionary for meat to animal, from which animal the meat is coming. So what we can do, we can create a new row, data.animal, which is not available right now, and on the data.food we can map this to this function, which is, what is this function do? For each element, what will happen, from food it will take bacon, goes here, it will check meat to animal bacon, meat to animal bacon, and the return value will be pig. So pig will be added into the animal. So let's first run this now. This, so map is very heavily used in your data analysis. Map, apply map, right? Next is the replacing value. So replacing value is, if there is some old value you want to replace, let's create one data series. So we can see this minus 99 minus 1000 is definitely not the correct value, and we want to replace this. So data dot series dot replace the old value and the new value, it will be replaced. Control Z here. Now if you want to have a two values, you can make a list and then the new value to be updated. So this will be updated with the enhance. You can also create a input, old values list, new value list, right? And also you can create a dictionary, both will work. Renaming axis indices. So let's create a data frame. Here we have four columns, 1 to 4, and Ohio, Colorado, and New York as the index. And what we want to do, we want to make this in the uppercase. So again, data, what's happening here? It is data. Go to its index. Map means in index, take each element one by one, give it to this function. So it will just update. So the output is all this value will be in upper cases, right? And as you can see, data is not being changed because the map function is not going to create an, it's not going to change the original values, right? Similarly, if you want to update that, you can directly whatever value is available. So in this case, all this value will be updated into the data index, and then the value will be added. So in case you want to update the, it will, you can use a rename. So it's going to create a copy. It's not going to change your original data, as you can see like that. Discretization at the binning. So binning histogram, which we'll see in the visualization videos. What will binning do? Binning is, so let's create a two list. We have ages and the bins, and we are, what we are going to do, we are going to use pd pen data frame dot cut. Cut is going to divide this ages into the category based on this bins, right? And interestingly, you will see its data type is category. It's a new data type, right? It converts all your data, in this case the ages, into the bins. Bins is means, it's, let's say you have 100, you want to divide it into four, right? And that will be like 0 to 25, 25 to 50, 50 to 75, like so. And you can see what are the codes. So in these codes are nothing but these values, and the categories are, these are the categories. So it's 0, 1, 2, 3 categories. You can see that these three categories has been divided like this. So which category these codes belong to, you can see in this array. You can call, so as you can observe, here it is bracket start with the normal bracket and closes with the square bracket. So what this mean, the, if the bracket is square, it's inclusive, means the value is considered in this bin, right? 25 is considered in this bin itself, right? And this means this is excluded, so 25 is not part of this bin. So that's what these brackets means. You can also add a group name, and in this PD cut ages be, and then assign, instead of 0 1, you will be assigned the group, adult group, middle age, and the senior. So what I was mentioning, let's create a uniform of 20s, and we want to these divide these 20 values into the four bin, right? And precision is nothing but after decimal values. So these are the four intervals. You can see the codes. These are the codes which belong to 0 to 1 to 3, right? And these are the categories of this particular uh, this particular value, right? Next one is let's create the standard normals of 1000, and again we'll divide into 4% quartiles, 20%, and we can count those, right? How many values are there? So if you submit it's 100, so 439 belongs to this intervals, next to this interval 68 to these values, and minus 2 to these values. And you can also divide instead of Python dividing your values, you can provide I need values in this intervals, and that's what it will calculate. Next one is the detecting and filtering outliers, very important. So let's say you are getting the observation of the ages and you see someone entering the ages instead of 3300. So that value will be the outlier, means the value is not related to what was the expected into the observation which you are collecting, right? So let's see we are creating a random norm from the standard normals, 1000 into 4 matrix, and let's see what is this. So maximum value you can see this is more than 3 right here. And if you want to see data of 2, right? So let's do that. And what we are doing in the column, we are making is absolute, so converting 0 minus value into the positive and checking if it is greater than 3. So we can see there are two values which are uh, greater than one value actually which is greater than 2, and let's select all the values and fetch from the data. If it is greater than true, check with during the column wise, and let's change the sign of it. So np sign dot data, what it will do -1 for negative values and 1 for positive values, right? And let's see describe. So as you can see, none of the value in the maximum is more than 3. It's either 3 or less than 3. So that's how you can control your identify. First identify your outliers and then change, do some analysis based on the values, what is your boundaries. Permutation and the random sampling, the last topic. So what will happen in this? So this is just let's create a one data frame. It has 0 to 6 values, and to create a sampler means permutation, it will generate 5 values, right, from 0 to 5. And what it will do, it will allow to fetch the data. So what we are passing data to take means it is according to this the index are being fetch of the index with the value 3 is fetch first, 1 2 like this. You can do with this with the iloc also same values. And also if you want to fetch the columns randomly, you can do using the first, let's create column sampler and passing the data dot take column sampler these values. And now instead of on doing on the index, we are doing on the columns, right? So 6 5 4 3 same order. Choice is another. Let's create a series with choice, and choice or sample means give me the 10 values and repeat it. If replace means repeat it true, right? Converting category variables into the dummy or indicator matrix. So this functionality will be more used in the machine learning and machine learning mostly any other statistical or data analysis part, where let's first create the data frame of key and values, and we want to convert these keys, right, ABC, into the dummy values or the indicator which highlights 0 or 1. Let's do that. So it the function where we are using get dummies on data keys on these keys and give the value output. So what it has done, it has created with this only with this column three values, right? There are three values A, B, C, and if value is 0 is B or B, so it is true. We can convert into 0, 1 using apply map. Now the values is more readable, right? 0, B is 1, like that. And we can prefix with the keys, right? There's nothing, just adding a prefix key underscore a, no much difference here, and joining with the actual this values. So this values dot join. So this were our values, and the key is now being transformed into the indicator matrix with 0 1. So let's take one example. So we have movies uh, data set, right? Movies data set, and these are the first 10 movies. And you can see the genre is the animation children's comedy. And let's divide this genre into the indicator matrix into 0 and 1. So what I'm doing, I'm taking these movie genres, right? str get dummies means if pipe symbol is there before that, make it in dummies, right? Let's first check the top 10 rows and the top 6 columns, and I can join this with this, right? So the first movie was what? Toy Story, right? And it has the animation children comedy. As you can see, the animation children comedy is one, others are false. So it's just converting all your categorical or variables into the numerical where for the analysis. It will be very helpful to to run the statistics on the numerical values. So that's why we convert the categorical into the numericals. So that's it for now. We'll continue our conversation on this data cleaning with one more video. Thank you for now. Hi everyone. So continuing our discussion regarding the data cleaning preparation topic. So let's talk about the string manipulation, which is very important. And let's first plot the libraries which we are going to use. The first one is we are creating a string, and it's a B one three characterized within separated by commas. And how to split that? So there are various inbuilt functions. There are functions we can use using the RE, right? And regular expression, that is RE stand for regular expression. And also there are the string functions available within the pandas. So let's see how to split that. So your string plus dot split is, and the in the quotation how you would like to split. So like in this case we have a commas separated, and as you can see these are splitted and created a list here. One thing to notice, in the third there is a space, right? So only where there is a comma it's split it into the three different words. What if you want to remove, or means do more data cleaning if there are spaces, and that usually happen if there data in the real time data, right? And for this, let's create a list comprehension. So what I'm doing, I'm again working on this list, right? Getting one by one, each element one by one, and using the R strip. R strip used to remove the spaces, right? So let's run this. And in this case, you will observe the third one, there is no space before and after the word. You can use, again, there are three elements you can store into the three, and also in the string, you can do the concatenation with the plus sign, plus whatever you want in between. So in this case, A plus plus. But the better way to join with any of the separators, right? Whether it's a plus, pipe. So you can use the dot join function using the on the word, right? It's a more Pythonic way to do the same task. What if you want to check whether the particular substring is available? So you can use in operator in this, right? A in sub true, and also you can use the index find. So what happened in the index? So it will give you the first pattern, right? With the position of the first pattern. So the comma is available on the 0 1, right? That's why the one is, and let's find the colon. So it is not available, so by default it will give you the minus one. So if it is available, then let's, if we try comma, right, it will give one. Also, if you try the same thing with the index, the value which is not available, it will throw an error, substring not found, instead of giving any minus one or any value. You can count using the count function, how many elements or the pattern is available, like comma is available two times. You can also again use the replace the old value with the new value, right? Like if you want to make three, it will be three. Regular expression. So regular expression is used for pattern matching, substitution, and splitting. right? You have to import using RE, import RE, and this is the text. And as we know, we want to, there are spaces, right, to separate these words. And let's do the split. So RE dot split, and using what, how you, how the split is being done, and on which text. So better way to use the RE regular expression is to, so what happened is first compile this part and then do the split, right? So there's always the best industries was standard is you first create your REX regular expression, REGEX. With this, I want to check with this, and then use the function. So it will be way better. You will save a lot of CPU cycles. Same output. There is a function called find all. So what it will find all the pattern matching in the given text. So in this case, you can see there is a space, right? There is a tab T two times. Let's move to the next. We have a text. It contains the name and the email ID, and this is the pattern we want to search. So what is this? So this is nothing in the pattern. It is A to Z or number dot underscore your ampersand plus minus plus the at the rate, and then again the domain name, and plus the .com or .co. It should be in between 2 to 3. Right, let's compile this pattern. So it will ignore the cases, so it will be case insensitive. And let's find all. So with it matches the pattern in this text and give us the results, like we saw all the email IDs. And the search will do rx.search. So it's going to check the first instance, right? And let me do that. So if in the RS search, in the M means the search, what I'm doing is just giving the start or the end, the first instance of the matching string. Next, the match will do. It will only check at the starting. If the first is not the match, then it will return the none. You can replace using this sub function. You can replace if something got matched with the text. So in this case, Dave, the email ID, and you can do anything, replace with anything. Let's in the pattern I have just added here the brackets, which will again the new pattern, right? It will group means if the email ID is there, so first pattern was the username, then the domain, right? And then suffix. Find all for all this, all the given email IDs. Suffix again, you can create a pattern. How do you want to see the results at in this Dave, right? The first one, the username, the first. Second will be domain, third is the suffix of the given text. Similarly, there are functions which are available in the pandas too. So let's create again the same data. So it's a dictionary, Dave, the name and the email IDs, and let's create a series using that dictionary. And let's check whether there is any. So you can see in the third one there is any. The email ID is not present, right? And you can also use the contain to check whether the given text is subtext is available in the text. Whether Gmail is text, yes, it's available in two, right here and here. So that's why it's two others. We NA is NA and the false it is not available, does not match. Similarly, you can use find all. It gave you the same checking on the same pattern and same result, and it is giving the list. So you can just put a first element and it will give the same result set. If you want to use the extra, it will return a data frame, the same values. So it is the index and these are the column and the same values which returned as the data frame. So for this we have used the extract. Categorical, we have seen this in the last videos also. So again, let's create a series, and this is the values and this is the dimension. So what happens, we want to map this dimension to the value, and we have to use what function? We have to use text, right? So, or we can convert into the categorical. So let's create a, if you want to convert this values into the dimension, you can use take, right? And let's create a new fruit and lens, fruit and n, and also create using that SCADA data frame. So what we have here is this data frame, the basket IDs, which is nothing but a range 0 to n. N is what 8, right? 0 to 7, it will get the values. Fruits we already have multiply by 2, right? 8 values. Count, we are just getting a random numbers from within 8, right? And the weight is again the random from the uniform data set, uniform distribution 0 to 4, size and 8 values. And let's take the fruit column and use as a, so what we'll do, we'll create this as a category, right? So let's see, so you can see the data type has been converted into categories. Categories, you can also check what are the categories available. Code, how many codes? So 0, 1, what do you mean by 0, 1? 0, 1 is nothing but the two type. You have only apple and orange, right? So if you want to see what are the categories, you can go ahead and run the C road categories. So why do we use the categories? Because the competition is very fast compared to the other data types. If you have the data type in categories. So let's create 1,000 draws, right? And bin PD cut is nothing. It will divide all your data into the four intervals, right? Quantiles, and the intervals are nothing but these are the four intervals, right? You can name it Q1, Q2, Q3, Q4. This is the same thing, only just I've added the labels. This is the code, and the category is what? Q1 to Q4. And you can create a series, and using a series, we can, what is a good thing about this? You can create a group with the series, right? So just to understand this line code, we have taken the draws, the 1,000 values grouped using the bins. We have how many category we have to bins? Four. Aggregated means created the columns with count, minimum, maximum, and reset the index. So this is the data frame, right? The four quantiles counts, right? This sum up to 1,000. The minimum and maximum in the Q1, Q2, Q3, and to again just to close up the category bars, you can convert any of the columns or series into the categories using as type dot category, like as type dot int or float similarly. And the codes represent the all the values, category represent the indexes, the types, right? And you can do uh, functions like value counts on it. Also, we have seen the last video regarding the dummy variable. So this is majorly used for the data in the machine learning and the modeling, where let's say you have a categories and you want to convert into the, how many categories are there? The four. So you want to convert each category as a separate column and gives the value 0, 1, right? So like this. So in this case, the first one was A, right? So A is 1, all are 0. So that's how you can convert the into categories. So what we have discussed in this one, so we how to clean the data, right? In the previous video, how to see the outline, how to find the missing values, change the missing value, fill those missing values, and also we have seen the categorical, the competition with categories, the string functions, right? The regular expression library. So this is on the very basic high level, and we'll now move into the next part of doing more grouping into the data set of the available data set before we move to the visualizations. Thank you. Hi everyone. So in this video, I would like to talk about the data wrangling, means uh, doing the transformation in the data, and we are going to cover these joins, like these major topics like joins, combine, reshape. And first we'll start with hierarchical indexing. So let's start and first load our libraries, the import pandas in the NumPy, right? And let's create one series. So in this series we have what what I'm doing is I'm getting the random number 9 and this is the index. As you can see in the index, there are two lists. The first list is this one and the second list is this one. So we can consider these as the two levels also, right? So the first one, as you can see, AAA, it is the first level and it has 1, 2, 3, right? B again two elements, C2 and D again two. And it so how to think about the hierarchical indexing? So it's you can think like it's a drill down. So if you pull data and in the square brackets A, so these three values will be the output, right? Let's see what are the index looks like. So index is nothing but a tuple. So A1, A2, A3, B1, B3, right? C1 and at the end D3. So what if I pull with the B index only? So B is this, so I should get two values, right? 1 and 3. And what about if I put a level 1, right? So I'm going into drill down B, give me the B and then level 1, so it is the 0.99. What about if I pull B and C? So as you can see in the when we use the quotations uh, as the index, so it gives both the values. It does not minus 1, right? So B and C using the iLoc also, you will get the same values. What is unstack? So unstack is nothing but it's going to give you, it changes the inner level index into the column name, right? As you can see, these were the inner levels, it moved into the column. This will become index and these values again, it got pivoted into the rows becomes the columns here, right? A1, A2, A3, A3. And if we do unstack, that will bring back the same values. This was the original series which we created. What about the frames, data frame? So let's create a data frame. Again, in this, it has 12 values, 4 rows, 3 columns, two level of indexing. Column is Ohio means it will divide into, again, column has two levels. Ohio will have green and red. Colorado has one, right? Let's see. So Ohio has two. First, let's see the indexing. One level, second level, right? Ohio has two. Colorado has one. If we see the index is nothing but a tuple of A1, A2, B1, B2. We can even change the name of, give the name of index like key1 and key2. So first one will become the key1, this will become key1, this will become key2. How many levels are there? How to find that? So frame dot index dot level. So it is two, right? These are the two levels. And even the we are columns, we have two levels. Like Ohio is the for level one, green, red is the level two. We can provide this is the state and this is the color. And if I just add and show you the frame, so the state and color has been added. What about the reordering and sorting level? So swap level function, what it will do, it will change these keys, right? So earlier we had the A1 is the starting, the first level in the hierarchy. Now it changed to key 2, right? You can use 0, 1 or you can provide the names, it do the same thing. What about sort level 1? So if we sort on the level 1, as you can see, this earlier it was AA, BB, now it's AB, AB. Because of we are providing level 1 at this, so it's again start with the 0 indexing, 0 level, level 1, and we are saying sort the index with the level 1, right? And here what we are saying, first swap it, make it 8 become key 1 values become the second level, and sort with the level 0. That's what we are getting. Let's also see some of the summary statistics by level. So let's group by with the level key 2, right? And if I show you what the frame looks like right now, so this is a frame, right? We are doing group by based on the level 2 and sum it. So it will group by with this level 2 and sum. So 0, 3 will become 3, right? And this is 12, which is correct. So if I, what is happening here is on the key 2, 1 1, right? 0 6 6 1 7 8 2 8 10. And if you go this 2 and 2 here, if you combine into the summation, 3 plus 9 equals to 12. And likewise 14 and 16. You can do with the column level also, right? Based on the colors, and it's doing the summation, right? 0 2 2 3 5 8, right? 6 and 8 14, 9 plus 11. So whether you want to do in this way or in this way, you can use the level and also the axis. You can use one for column, or you can write the exactly the word column and do the summation. Next, let's see the indexing with data frame column. So in this data frame, we have column A from 7, 0 to 6. It is in the B is in the different order. 7, right? 7 to 0. This C is 1, D is 1. Let's see. So we have Z 0 to 6, 7 to 1, 1 to 2, D, whatever value we have given. So this is the data frame. So what we are doing, set index C and D, means take the C and D and move this into the index. This is a new frame, right? C and D moved into the index. So in and see what this becomes is one level, second level, one level, second level. You in this case, if you see the C and B has been dropped, right? But if you don't want to drop this value, you want to keep the value as intact, so you can keep drop false, and now C and D column are already are there, and it didn't drop. What's the reset index to? It's the opposite of set index, right? It will just remove the indexing and move those into the columns. Let's see the combining and merging data set. So in this, we are going to use three major pandas merge, pandas concat, and combine first. So pandas merge, let's create two data frames. This is data frame one. It has two columns, key and data one, and this has another data frame, the key and data two. So if we do merge data frame dot merge into data frame, what will happen? It's check the keys here, right? And check the keys here and do the inner join kind of operation. If you are familiar with the SQL, this is the inner join operation. You can use the pandas pd.merge, it will give you the same output, right? And if you want to specify on which key, right, you have to perform. So it's the same thing, same output, because it's take the first column as the key, right, and give you the merge these two data set. Let's create two more data frames. In this, we have L key and write key, right? Data frame one, L key, data, data frame four, this. Now what we are saying, left key is L key and right key is the R key. We are providing these two additional parameters, and as you can see, the column names are different. So in the previous one, what's the main advantage was the key was the main column name which is the same values, right? But here it is not the case. If the columns are different, you can provide those parameters like left one is this, right one is this, and now merge the data. There are many types of merging, right? Left merge, right merge, outer merge. So the outer merge works like the union, mean it will take the distinct value from each and combine those. And you can perform same thing on the fn3. It takes the outer, just take the union of those two different data frames and combine it. Let's change the data frame again. Df1 we have key1 d1, and df2 we have this. So in this we are doing what, left. So if you see in the data frame one, we have b how many times, 3. and this how many times? 2. So 3 into 2 is what? 6. So we should get b multiplied by 6 and likewise the other element. So this is what is referred as a Cartesian product. You can, if you are not aware of, you should, I would definitely recommend to check the outer joins and how the Cartesian works. So there is a Venn diagram, very famous. You can just check that. Again, you can do the inner join, you can do the right join. You just have to provide what kind of a merge. Merge and joins are kind of a similar, like you are just merging two different things and you want to see, tell the Python how do you want to merge, you want to use the union, you want to use the left, you want to use the right. Let's create the data frames left and right. So this is our data frame which is key 1, key 2, I well, right, left well, right, and key 1, key 2, R value. So now if we do left one right merge, so what it will do, it will check on these two values, right? 1, 1, 1, 4, 1, 4. So I did the inner join operation and let's do the outer, means the union. Right now we have two null values. And if you want to specify on which key you want to perform, so you can provide those in the key, like we write the SQL sys star from table 1 join table 2 on means the which key of one key first table and the second table. Similarly in this case also you provide the on which column you want to perform the joins. Suffix is just you can add the like which is just to identify. So it's an option for specifying string to append to overlapping name in the left and the right data frame. So that's what suffix is being used for. So right now we were doing the merging based on the column value. You can do also merge using the index. So let's create a data frame. So this is our data frame. It's a key and value, and right one is this, right? A and B. So PD, what we are doing, PD merge, we are merging left and right on left on key, right? Based on this value, and right index is to this what it indicates, the index should be used in that merge. So you want to see the right one index should be used. Again, you want to include this is the inner one, right? If you want to use the union, however it was, keep the outer. So let's create a few more examples. So in the left, we have a data frame. This is a key one, first column, second column, third column, right? And uh, this is the data. In the right index, what we are doing, we are using PD multi-index from Era. So in Era, we are just creating a hierarchical indexing here, and let's use that, right? So what we did, we have used the event or PD series. Index is this right index. These are the two values, and now let's merge on the key one and key two. So interestingly, you see that it has on based on it is left on key one and key two, and also using the right index, it has merged these two values. So if you see Ohio 2000, Ohio 2000, the value is 45, and what about the above? Ohio 2000, the value is 0. So value 0 and value 2 type, so this merge into this one, right? Next we have Ohio 67, and do we have value above? So because it was 0, it will 067. So using the right index means this index, right index, we are merging these two. Here just we are adding the additional parameter of make it outer. Outer, as I told, it's a union. So let's create a couple more data frame, left one, left two and right two. And if you merge the left two, now we are doing what? Left index. Based on the left ABC, we are merging these two data frames, right? You can also use the join. As I told, the join and merge are very similar. So it's gave the same output with less uh, You just have to write which data frame you want to join which and how you want to join this. Let's add one more data frame and join three. So left two, we are going to join right two, right? Right two is what? This one, and the other is this one. Let's see. And now let's keep join the do the outer join. So last topic, I think for this one is the concatenation along an axis. So let's create an array. It's a shape of three rows for columns, and let's concatenate means we are adding these two together. So you can see this three, that's how it's been added. If you because we are making axis zero, you can make zero. The it will add based by the axis of rows. Let's create three different series. So if you want to concatenate, you just pass those series and it's 0, 1, 2, 3, 4, like that. You can, this did row wise, you can do the column wise 0, 1, 2, right? And you can also provide the keys 1, 2, 3, like this. So this will create the indexing of 1, 2, 3. Unstack, if you remember, the unstack is used for just to pivot from the series type or if the values are in the longer part, right? They are A, B. Now the inner, as I told, the inner index will move as the columns here, right? And the outer index become the indexing, and all the values will be pivoted into the longer part. If we do this similar thing of concatenating, which we did earlier, and let's create a data frame here again, right? We have one data frame of 3 by 2. This is the index, this is a column, and we are just adding 5, and let's concatenate. So concatenate, we've just provided the 1 and 2, right? A, B, C, A, C. So this is, if you're not providing this, it is going to take default as x is equal to 0. If you want to do the column wise, you can provide the x is equals to 1 and all the values will be added. Here, interestingly, we also pass the keys. Keys are nothing but the first level in the columns. We are in this next, we are just providing the names. This the upper level and the lower level. If I run this, and this is what upper and the lower level. So let's create a series, two series, and we can see whether if PD is none, A. If yes, then the value B as the value A. So this is what it's been. And the same thing you can do with the combine for. So if there are missing values and you want to combine two different series, you can use the combine first. Similarly with the data frame. So we have two data frame there. So 1, 2, 3 indexing ABC, 1, 2, 3, 4 indexing ABC. There are some of the non-value NA values are there. And if you combine these two, if the value is available in different, so it will combine and replace that value from the different series or data frame. So we'll continue our discussion on the data wrangling part. This is the first part. I will just create the one more. There are a few more topics to be covered before we move into the data visualizations. Thank you. Hi everyone. So just finishing up our data wrangling session in Python, this is the part two, and in this I will be talking about the reshaping and pivoting. So which include the stack and the stack, right? So let's first go ahead and load our libraries, both the NumPy and the pandas. And what we are going to talk about is the reshaping and the pivoting. So in that comes the stack. Stack means converting your column based into the one single column data structure, and unstack is the reverse of that. If you have a series kind of a structure and you want to move, maybe pivot from your row based values into the column based. So let's first create a data frame. In this we are taking six values, 2 by 3 matrix. Index is Ohio and Colorado, and we have three columns, right? and it says a number. So now what if we do the pivoting, right? We stack it, means convert all the columns into one single column, right? And let's do that. And result is something like this. So what happens? The states, uh, the number, this columns comes as the one single column, right? And all these values is converted here, and these are the indexes. And the on the other hand, the unstack is nothing but reverse of that, right? You do take the result, do the unstack, and you get back to the original data. Next, you can do the unstacking based on the levels, right? Levels, and on the levels, you can provide the zero, and in this case, also you can provide the level states, right? These are the states. Cool. Let's create a couple of series here. We have four and three values, and what I'm doing, I'm just concatenating those. These S1 and S2 keys is 1 and 2, and let's see what the data 2 looks like. And if we do the unstack, it will convert all this, take this into this particular index into becomes the columns, and unstack becomes the same original one. One thing you realized, it's removed the NAs, right? So there are NAs. So what are the values here? It has A, B, C, D, E, right? And what we get here is in the 2, there is no A, there is no B. In A1, there is no E, right? So if you do drop NA false, you will get all those three NA values also. And in the data frame, what we have the left as the result, and we are just adding the right plus 5. Nothing major here. So let's do the unstack. Unstack is nothing but converting your, this part will be converted into the columns, right? And also when you unstack in the data frame, the level unstack become the lowest level in the result. So let's do that, right? And also if you do the unstack and using the level state, means unstack using this, and level is site. So based on this, we are doing the unstack again using the columns and creating those columns in using these columns and creating those into the rows. Pivoting long to wide format. So I have a data macro data, right? This is the data. It is 203 rows and 40 columns. And what I'm doing, I'm just taking what I need is a year, quarter, real GDP, inflation, and unemployment. So what this means, give me all the rows and only these columns, right? So data has been updated. Now, instead of this index, I want to make an index of this year plus this quarter. So here I'm using a period index function, means I'm popping out, deleting the year and the quarter and combining those as a date, right? So this is what the period looks like, and now converting this period into the time step, and that has been changed. So data and putting that into data index. So data index looks like the dates, and these are the columns. So next what we have, we can do, we are doing the re-indexing and putting the column names as item, right? If you see this head, this is again just adding the item name here, right? And now we can do these stack. Also, we are going to re-index and rename with the value. So what happens here? The item date we have already have, right? We got the index and the item, these columns converted into the rows, and also these are the values. So stack means converting your columns into the single column. We can do the pivot, and it's just the same thing. You have your long data, right? This we convert long data, pivot it into with the index is our date, columns is the item, and the values. So this is the pivoted data structure. We can add value to one more column here, and we are using random from the random library standard normals for the length of this long data. So the one new column is added here. We can again pivot it with the column and date side. So this value 2 and value has been divided into two separate sections. And you can see, you can also, if you want to see, I want a value head, right? So this is the value and these are all the data. So this is one section. This is the unstack, and now we can also pivot from wide to the long format. So let's say this is our data frame, right? And you can use the melt. So melt is nothing but it inverse whatever the pivot used to do. It just changed it, right? So we have a key, and all these columns is just converted into one single variable and the values. You can do a reshaped. We are just pivoting it this into uh, doing the pivot of this particular melted data, right? Using the index as the key, column as the variable, values as the values, and this is a reset function. You can do the index is not there, so you can reset the index. And also you can, instead of using all the columns, you can use this, the sub values, right? So here we are using the AB value, ABC, and AB. So that's what we have: a melt, we have the pivot, and also we have seen the uh, loading the data, stack and unstack. This is what the reshaping and the pivoting looks like in the data wrangling. And now next we'll move into the visualization part in the Matplotlib library. Thank you. Hi everyone. So we have covered a lot of topics in the data analysis videos in the earlier videos, and now I would like to talk about the visualization part, in which the the baseline, the very basic, the Matplotlib is a very basic visualization library which you can install it using Matplotlib, right? And that is what I'm going to showcase, the various component of the library and how you can use it to create the basic charts, basic visualization using the Python Matplotlib library, right? So let's first, we are going to load our library. So I'm loading here the NumPy, the pandas, the Matplotlib pyplot as PLT, and let's create our 10 values, right? So using NP NumPy array arrange. So these are the 10 values, and if you just do a plt.plot using the data, that's going to give you the straight line, because what it does, it uses the data points, right, and create a, just plot that point in the straight line, because it just starts as 0 to 1 to 10, right, 1 to 9, and that's what the straight line is. So the PLT here is nothing but the matplot pyplot alias, and we are plotting it on the data which we just created. And the by default, the plot function is the line. So whenever you do a plt.plot, by default it just create the line graph. Next, let's first see the figures and the subplots. So there's a figure function in the pyplot where you can call and keep as the figure in the fig fig. right? And in that trick, you can just add multiple subplots. So what is 2 to 1 represent? It's represent there will be 2 by 2, means 2 rows, 2 columns, and 1 represents the one first axis. Okay, and this is second and the 3. If I just run this, you see there are 3 axes in the figure, and this one AX1, this one AX2, this is AX3. So let's plot something on the X3 in this part. What I'm doing, I'm just plotting, getting the 50 points, accumulating, doing the cumulative summation of that. Color is black, line is dash, and the by default is going to plot the line. Let's see what it's going to do. So it just plotted the line for the 50 random values doing the cumulative sum. So if we just do it again, you see why there are two lines, because I created on top of it. Let me rerun. So we do have one only. Nice. So let's also plot in AX1, in this one the histogram, and this in the X2 the scatter plot, getting the 100 values there, 20 bins, and the alpha is just the transparency. And let's see. So this is the AX1, and AX2 also has the values. You can create a, if you can use the Pythonic way to create the subplots, right? So PLT subplot represent there will be 2 rows and 3 columns, right? And this is the axis. This is the axis, 2 rows and 3 columns, right? And these are all the axes where you can create individual plots in this axis. What about the adjusting space around these subplots? You can see there are space, so these are the by default. But if you want to change that, you can do this. So what I did in this code, I created 2 by 2 subplots. Share of x and y argument is true, means each plot is sharing the same values, right? So 0 to 60, 0 to 60, minus 4 to 4, minus 4 to 4. And for each plot means it start with I1 and Y1. It is going to do the histogram for 50 points, pin 20, color this and alpha. And the width space and the height space for the subplot we have adjusted to 0, so there is nothing. That's why you can change the values if you want, and it will give the same result. Next, let's talk about the colors, markup, and line style. So let's create a figure in the X1. We are just adding one X1, and we are plotting it with the 30 point community sum and line dash and mark code. So this is the addition part, which represent the point where the value is changing, right? You see one value, second, three, four, so you will find 30's values there. Also, let's create, so in this what we are doing is creating additional plot. So this is the first plot, this is the second plot, and the draw style we are keeping the step post. So it just change where the value changes, it just draw the different plot using the draw style of the step post. Text labels and legends. So text labels are nothing, we'll be talking about the axis, and let's create one x plot. So this is empty, right? In the, if you can see in the x values there is nothing, in the y values there is nothing. So let's set the ticks in the x, right? Ax dot set x ticks, means x ticks means this part here. And what we are sending, so right now the value is 0 to 1000. We want to make it only 5 values, so 1, 250, 500, 750, and 1000. Next, we are going to put that into the X labels 1, 2, 3. So instead of this value, it will show 1, 2, 3, 4, 5, and it will be rotated 30-degree, and the font height will be 8. So let's set it, create a title, and show the fix. So 1, 2, 3, 4, 5. So these are the labels we created. It is 30-degree, and this font size is 8. Also, we have added the name of this X labels, right? Call this stage, and the title is matplotlib. And this is what the actual full figure. One thing you notice, there is no legend. So how to put the legend? So let's create a new figure. We are creating 3 plots in it. right? And if you notice, we have added a one additional argument, the label. Label means for this plot, it is no legend. I will talk about it. Let's first keep it first, right? And you see what this ax dot revenue, it will just call on this labels and display that into the best. So there's a location also currently it Python the matplotlib calculate where the best the legend can be shown. And if you don't want to show the legend, so that's first you can put this no legend underscore knowledge underscore and the first legend will be removed. You can also do the annotation means let's say you want to annotate something like this. Here you can do the annotation. There's a one small code where during the financial crisis was a major the incidents happened that to highlight those like so this is in this chart we are going to do the annotate on the subplot. So what we are doing, we are reading data spx.csv file, sorting the data index. Then we are from the data, we are just only pulling the SPX column, right? And let me, uh, and we are going to plot AX, the whatever X is there, X is right, color black. This is the crisis data. So on this state, the peak of bull market was there. On this state, the Bjornstone bank got failed, and on this state, the Lehman Brothers declare their bankruptcy. So for each date and label, we are going to annotate. We are fetching the label and the X for to put anything on the chart, you need to provide the coordinate, the X and Y. So XY is the date, right, on the x-axis. SPX value on that date plus 75 means it will show above 75 points. Next, we are finding the text. What is the text we have to display? And some arrows and the alignment of it. So if I run this, so this is what uh, looks like. So on the date of 2007, so this is something in 2007 of 10th of month 11, the peak of the bond market, right? And this is the time when the bear still failed. This is the Lehman declared the bankruptcy and that the market got fall. The last one is how to save the plot. So fig.save is the command you use to save the any. There are multiple extensions, more majorly used on the PNG. If you want to do something, you can use that. So that's what I have on the Matplotlib. I will continue this and we'll have more discussion on the Seaborn and few more on the charts in the Matplot and also there are the baseline functions available for plotting in the pandas in the data frame and the series. So we'll talk about that. Thank you. Hi everyone. So we discussed regarding the Matplot library in the last video, and I just want to take that conversation discussion ahead with some of the visualization which are available in pandas and also to introduce the Seaborn library. So if you don't already have the Seaborn, you can use the pip install Seaborn and I'm going to load the libraries, the pandas, the NumPy, the Matplotlib and the Seaborn. As I told, when we use the dot plot, the default graph which is there in the in the visualization is a line chart, but you can change. You can use the bar, you can choose the histogram or other different type of plottings. So let's see what the line plots looks like. And in this, I'm going to create the series of the random number from the standard normal distribution. Then and doing the cumulative summation of that. Also, the index is 0 to 100, but with a step value of 10, so it will like 0, 10, 20. And if you want to see what's the series look like, and it's like it's 0, 10, 20 is the index, and these are the values. And if you just directly do the s dot plot, what it will do, it will create the line plot. You see, So index is nothing but these values, right? 0 to 100, 90, and the values, whatever value is there, it's just being plotted here like this. What about the data frame? So similar concept is will be applicable in the data frames too. So let's create the 10 by 4 matrix with the cumulative sum. 0 represents it will do the cumulative sum of the rows, right? Index is again same and the column represent A, B, C, D. So this is what the data looks like. And what we are going to do, let's do the data frame dot plot. So for each column, right, for each column A, B, C, D, it just created a line, right? As I told, line is the default for the plot function. And you can use the different styles. There are different styles are available. Like in this case, let's use the grayscale plt dot style reduce and then now plot it. So it will be different plot from the previous one. Let's look at the bar plot. So bar plots are of two types. You can have the horizontal bar or the verticals. For the vertical, you can use dot .bar, right? And for the horizontal, you have to use bar_h. So in this way, I'm creating the two rows, one column subplot. This is a series of size 16, and the list is A, B, C, D. So these are will be the index. And doing the bar plot data. So whatever data we are doing plot dot bar on the first axis. So as I told, there are two rows, and this will be the second. So let's see what the results look like. So the first one is the bar, the normal one. It is a vertical, right? And if you want horizontal, you can have BARH on the same data, same values, right? You see ABCD on the for the verticals, right? On the x-axis, now the x-axis has been converted into the y-axis. Let's create one more data frame in this. It's 6 by 4 matrix. The index are 1 to 6, and this is a column A, B, C, D, right? For columns, and we have also added the legend. Legend is nothing but the name of the column. And if you do the df bar, it will be for each value, for each index value, there are four values, right? So bar plot will be plotted here. And the legend are these are the columns. For each column, the values each row, and for each column, the single bar is being plotted here. Similarly, if you do dot barh, same thing will be converted into horizontal bar. But if you type the stack true, so what will happen instead of creating a separate bar, it will stack into the single one. Means each column, each row value for each index will be stacked into the one bar. We can take one example here. Have a CSV file which consists of the tips, and let's see the data. So it has these column the total bills, the tip given, who is the person, male, female, is the smoker, what is the day, it's Monday to Sunday, and what is the timing, and what is the size, how many persons are there. So what we are going to do, we are going to use the pd.cross tab on the day, on this, and on the size, on which day, what is the size of means how many number of peoples are there on the party count. So what it will do, it will create a cross tab means on Friday for one side the value is one, and from Friday you can see the two peoples are total count is 16, and Thursday we have like this. And we can do the re-indexing of Thursday, Friday, Saturday, Sunday, right? In this order, same values, we create a new index. Next, because the value 1 and 6, it does not have a significant number, so we can remove those. So all the rows 2 to 5 will be there, right? And now instead of using the numbers, what we will do, we are going to normalize, which will all the summation is going to 1. So what you can do, the party count.div, and the count of the summation of all the x of the column, and index will be axis will be the index. So these Thursday, Friday, Saturday, if you do the sum, so it will be the value 1. Okay. Normalizing is basically used in the machine learning, also which we'll discuss when we deep down into the machine learning topics. So let's plot this. So we have this percentage, right? Plot, and we are going to the bar. So for each index, there are four values. For each index, there are four values that been plotted here. And you can do the stack bar, right? And to get the insight, you can see on the Thursday, Friday, Saturday, Sunday, the size of people is more, right? And that makes sense. So there are on Saturday, Sunday, there are the size is increased, right? The number of people is being increased because of the weekends. We can also collect the tip percentage. So tip divided by total B minus tip. And this is the value. We are just creating a new column. These are 6% tip here, right? And yeah, 19%. Likewise, you can do the bar plot for the tips, right? For Sunday, you can see the tip is more compared to the other. And you can also add the timings, right? Whether it's a dinner time or the lunch time. So that's being added here using the hue argument. And also, we can also create the histogram and density. Let's look. So histogram, you divide your discrete data into the bins, and in this case, we are going to use the tip percentage. We are going to close and be the histogram and the bins of 50. So in the bins of 50, it says divide the value and represent. This is the percentage of the tip, and you can see this is a frequency compared to the percentage. Density is very similar to this histogram. For use to use this plot or density, you need to install the SciPy if you don't already have. And this is again the same thing, representing of histogram into the one singular chart called the density. So it shows the where are the most values are situated. Let's create a two no, standard normal values to 100, and this is the second, and we are just concatenating, means we are just adding and creating a single series. And let's single series, we are going to do the his plot for bins 100. So you clearly see this is a comp1 and this is a comp2, right? Next we have the scatter plot. So scatter plot is we have the values, right? We have a data called macro data, and these are the columns in that. I'm just removing the unwanted columns here, keeping in data, making it into logarithmic, and if any values are there, it's going to drop there. Let's see how the data looks like, right? And let's plot the regression plot for this. So now, interestingly, I have start using the CBONS, as you can see, SNS.regplot, and while using that, you have to provide three arguments that are mandatory: the X value. So M1 is the X value, unemployment is the Y values, data which are using the trans data which we created here, and that's what it also shows the regression line which fits in this data, and as you clearly see, it's very scattered, right? And if you want to see the if you want to plot all the columns in the data, you can use the pair plot to see different kind of data. Let's plot that pair plot, and you will see the densities compared to what it will do. It will compare the data, so CPI with CPI, right? And you can also see diagonally how the data is being scattered, or if there are any relationship, if there is a correlation, right? If there is a a negative correlation, positive correlation, you can identify using the pair plot. There are many arguments available to explore on this one. We have a facet grid for the categorical data. So if you have a categorical data, in this case, we have the date, tip percentage, and smokers, right? And smoker was the one. Let's see how the results look like. So what we are doing, we are dividing based on the time, right? And also the column smoker. So smoker is no, smoker is yes, and time of the date. That's how data is being divided. Here we are dividing also based on the time and the smokers, right? Time and the smoker. So if it is time is decor, smoker no, time is dinner, smoker yes, time is lunch, smoker yes, right? So you get a lot of insights based on your data sets. And the last one is just a box plot. So I'm using the cat plot and the kind is box. So earlier the kind was bar, right? So it's going to bar plot. And this is the box plot, which these are the outliers and this is the median value. This divide the box plot divides your data into four quartile, 25%, 50%, right? 75%, like that. So this is a very basic introduction of the seaborn and the pandas inbuilt available plottings, and also we discuss on the on the matplotlib. So this give you the very basic understanding of how to use your data, how to plot them, and start developing and getting some basic insight from the data. Thank you.
Hello everyone. So in this video, I would like to share more information regarding the data aggregation and the group operations. When we have categorized or different type of data, the aggregation and transformation is very critical component in the data analysis, right? There are many things we can do. We can group the data and apply multiple inbuilt functions, or we can write our own functions. So in this couple of video, I would like to discuss on the data aggregation and the group operation and related function around those. So before I start, I want to also discuss about this split, apply, combine methodology. So what this mean actually is when you do any group operation, right, any data aggregation, how the internal operation take place is your data is there, right? It it first it get into grouped, means it gets split, and then the operation. Let's say you want to do the summation. So this is the data, right? And it is against we are grouping based on the key. So we have A, B, C, three groups, and now we want to sum it. So A will be summed into 15, right? And B will be summed into this 30 and C will be summed into 45. And then the last part is a combine. So all the group will be combined together to form one data frame or the series kind of a structure output in Python, right? So let's first start load our libraries and let's create one data frame. So in this we have key one, key two, uh, data one and data two. So this is a data frame, right? And let's compute the mean out of it. So before we do that, let's group it. So what we are doing, we are uh, data one column. We are taking one and grouping is based on the key one. So it will be A B group, right? And I'm putting that into the variable called group. So as you can see, uh, we are supposed to see the result, but it did not give us the result what we were expecting because it group means we are currently in this stage in this state, and you can do more operation on here, right? It already grouped and we will be doing mean of the group. So as you can see in this A and B are the two groups, and what it did, it provided the mean. First it grouped this and provided the mean of data one column. You can directly what we are doing, we are grouping data one again, group by key one and key two. So now A1 will be one group, A2 will be second group, and we are doing the mean. So we are directly getting the result. This mean we can do the unstack, right? We can convert. So what when the unstack happens, the inner index will convert into the columns. Now let's move to the next part of it. We have these states and the years, right?
And what we are going to do, we are going to do a grouping based on this date and years. So how this will happen? So again, this is not a part of the actual data, right? DF, but you can group with by providing the additional list series, and you can use that in grouping. So in this, CCAOH will be grouped based on with respect to their years, and the data one will grouped based on this particular state and the years indexes. You can directly do the group by and create do the aggregation function like mean, right? So what you do, group by key one, group by key one, and provide the mean of data one and data two. Group by key two, provide the data one. You can again combine these two, key one and key two, and do the means, right? You can also get the size, and as you can see, all this operation, the NA's values are dropped. But if you want to keep the NA's value, you can put additional parameters that you drop NA equals to false, and it will provide you the NA's values too. Again, you can do the counts operation also if you want to count the number of observation between data 1 and data 2 based on the group by the key one. Next, let's look at the iterating group over groups. So in the key one, so in the data frame, we are what we are doing, we are creating a group using the key one, and we are iterating using the for loop. So name and the group, and first it will print the name and it will print the group. So we have two groups here, right? Key one, if I go up, so key one has two group A and B, right? And A and B, and what it did, it just provided the first group, first the name, and then the actual group, all the data. Again, if you want to make a tuple, you can do that with the group and first values, right? Group A1, A2, B1, B2, and this data. In this, what we are doing, we are again doing the for loop and creating a dictionary. So this is a dictionary comprehension where name and the group will be converted into the dictionary. Right? This is A first, it's key, and B and it's key. And you can extract those if you want to see on the B data. So this is all the B data. Next, selecting the columns and subset of columns. So again, this is the same thing which we did. So if we have a group, we are doing the group one, and we want to extract by group after grouping the using the key one, we can extract the key two and its mean, right? So again, you have to put down your function, then only you can get the result, else you will get the generic group as the output. Here we are extracting the data 2 based on the two keys, right? Key 1 and key 2. As you can see in this index, we have key 1, and in the index, we have key 1 and key 2 together. Next is grouping with the dictionary and the series. Again, let's create one data. We have a data frame. We have a data frame with 5 into 5 matrix. The columns are A, B to C, and the indexes will be Jaws, Steve, Vanda, Jill, and Tree. So this is what the data is, and what we can do, we can create one mapping: A equals to red, B equals to red, C equals to blue, and this is what we have the mapping. So what you can do, we can group these people to group by using this mapping, and we want to do mapping on axis. So A will be converted to red, B again red, C will be blue, red, orange. So we have how many groups? Three groups, right? And let's see. So we have, okay. One thing I would like to highlight also, as you can see why the third group is not there, because F we have kept orange and there is no F, so that's why it's been discarded, right? So now if you remove the orange, then all the two group left is blue and red. You can do we can create the series and again use the series and count the number of the observation with the same result. So the idea here is you can, in the group by mapping, you can use any additional outer mappings. You don't have to use the existing one, or you can use the outer. Like in this case, we did the mapping. right? We created one mapping and also we above we did with the states and the names, right? This one. So now let's move into data aggregation. So we have this data frame like key1, key2, data1, d2. And if you want to get the information of this data frame, there is a inbuilt function called data info, which is very efficient. It will give you all the detail regarding the columns. And let me run that first. So what we have here, it's a class of the pandas core frame data frame. There are 7 entries, right? 0 to 6, 0 to 6. This is the index. Then the columns, there are 4 columns, 0, 1, 2, 3. How many no-null values are there? So as you can see in this we have two no-nulls, right? So 5, we have one null, 6, and that there are no nulls, so it's a 7 values. So let's do the group by using the key1, right? And it's a group, and on this group we can again use the any other function mean, sum, and smallest. So it will give you the smallest function number in that particular group. You can write your own function. Like in this case, what I'm doing is peak to peak means give the maximum and minimum and subtract out. So let's say the maximum value is 100, minimum is 10. So the answer return, it will be going to return what? 90. So in this group, we are going to use AGG, right? It's aggregated function, and you can provide your inbuilt function or any user-defined function, like in this case, peak to peak, right? And it will give you, okay, let me to run that, and it will give you the result. So in this A and B uh, key one, the difference between the maximum and the minimum is this. And again, you can use describe, it will give you all sort of statistics. What is the count, mean, standard, quantiles of the data one, and similarly for second group of the data two. Let's do one example. So I have one data set tips.csv. You can get it from the internet, and let me load that. And I will just drop this to sex and time columns. And this, let's see what the data set look like. So it has total bill, tips, whether the smoker, day, and size. And let's add the third one more column where tip percentage. So tip percentage is what is the percentage of this tip based on the total bill. Now I did what I did. I did group by based on the what day and smoker, right? And let's run the aggregation here on the tips PTC, right? Tips percentage. So we grouped using day and smoker, and this is the mean of of the tip percentage. Again, I told you you can use the AGG and provided the functions, multiple function, it will give you the result set on the day and smoker. It means a mean, sum, standard deviation, peak to peak, right? And if you want to change the names, so you can provide average. So mean will be converted as the average, and NPT is converted to standard deviation. So you can create a list of all the functions, count, mean, max, and provide that. So first group, I want to see only the grouped value of tips percentage and total weight aggregated by will this function, and this is the what results look like, right? And the next one, you can also use the dictionary. So in the group, if you want to see the maximum of tips and the sums size you want to sum it, right? You can provide again the multiple in the dictionary multiple functions you want to apply to that group, and that's what it is on the tips percentage, right? We want to see minimum, maximum, medium, and standard deviation. Next one is the returning data grid using without the row. So this is nothing but we have as index, you can see the day and the smokers, right? So you just fill up the values on the index and move those index into the columns. Okay. Instead of what exactly it means, you have whatever the group you have created, instead of seeing that into the index, you can see as the columns. Okay, so let's also see the apply, split, apply, and combine action. So What I have created a one user defined function two, where I'm taking input as the data frame, number of observation and the column, and I'm returning these sorted values of that particular data frame based on this column. Ascending is false and it will show the numbers, right? So I'm applying tips as the data frame for six values. So tip percentage it shows from ascending to descending. So this is the highest tips was given by this. So the total base was 7.25 and the tip was giving 5.15. So that's the like almost 70%, 71% of the tip was given. Right? You can apply again. You can apply is the inbuilt function, and you can provide the top right this user defined function, and it will give you all the result set based on the smoker. A smoker is a group by and it will on all the other existing column in the data frame. Similarly, I'm just using the smoker entities, apply and providing the other arguments in the tops. Describe I've already discussed, so you can first group it and tell the Python on which column you want to see the inbuilt statistics from the describe function. That's how you can, and you can do the unstack of this, right? Converting your columns into rows. And if you don't want to see the hierarchical indexing, you can just apply directly group key equals to false, and it will remove the indexes and only show you the numbers, the index number, and with the other columns in the data set. So there are a lot of functions we covered in the data aggregation and the group operation. I have one more video. I will showcase and continue our discussion on this group operations using the inbuilt and the user-defined functions. Thank you. Okay, so continuing our discussion regarding data aggregation and the group operations is the part two on the same topic, and we'll start with the contact and the bucket analysis. So let's load our libraries into the environment, and we are creating here the first data frame, which has two column, data one and the data two. With the random, we are getting all these random values from the standard knowledge, 1,000 values per column. And let's first see the top five values. So these are the five values. And next we are going to use the pandas cut function, which where we provide the columns and the size means divide this particular data one into the four size of group and assign that into the quantiles. So let's see the four groups we have. So as you can see, the four groups are here, right, in the bottom, and these are the first five readings. Next, I'm creating the user-defined function, which is taking the group as the parameter, and it is returning one data frame, which is the minimum of the group, the maximum, the count, and the mean. Right? Let's run this. Now in the frame data frame, we are grouping based on these four groups. So all the data is divided into four group and will be kept into the groups. And in this group, we are going to apply this inbuilt function. What is get stats? So as I see, these are the four groups, as you can see in the index, and the four functions output the minimum, maximum, the count, and the mean is visible here. You can do this same operation using the aggregation function and providing the uh, functions which you want to apply on the group. So in this we have five functions: the minimum, maximum, the count, mean, and standard deviation. Now let's talk about the filling missing values with the group specific values. So this is going to be very helpful when you do the data analysis, because none of the data which we get in the real time uh, is perfect, right? There are going to be the missing values, and the one of the ways to fill and how to fill those missing values, we can use apply these codes here. So let's create the one series. We have six values, and let's keep make the second value as the nan, right? Starting with the first, second, right? And now to fill this uh, NA, there's a function call on on the series itself, fill NA, and we are calculating the mean. So if I just say what is the mean of this series, so it's 9, and we want to apply this field and fill it in the NA. As you can see, the same values is filled in place of the NAs. Let's create two list states and the group key. And in this next we are going to create the series of 8 values, right, and keep those indexes as the state. Okay, this is what we have. And let's make the Vermont, Nevada and Idaho as the NAs. Again, you can group this based on the data group key. So group key is what? East and west. So we are grouping all this data into east and west and calculating the size. So what is the size is 4 for each, right? Let's keep the group by using the group by in the group variable. And again, using the on the group, you can use the aggregation function and apply multiple function. If I can run this, and you can add as many as when you want. So like inbuilt function, I want to mean. So minimum, it is also calculating the minimum. You can create the fill mean. So what is it? Just taking the group as the argument and filling the NA's value if there are any with the mean value of that particular group, right? If I run this, so the earlier the these were NA's, right? Form out and all these are filled with the group group means. First is calculate the mean and then update the values. Next, let's first see one of the example of the group weighted average and the correlation. So we are creating the one data frame with the categories having 8 values of A and B's. Then the data is from the standard normal distribution and the weight from the uniform, right? Let's see, this is the data frame we have. And we are doing the grouping based on the category means there will be two groups. And in this user defined function, I'm just taking one group, calculating the average and the weighted average, right? So we have two groups and this is the weighted average of that particular group. Next, let's look up some of the stock data we have. So stock underscore px CSV, there's a CSV file which consists of some of the stock data of SPX and the other companies. So we have 4 columns here. The first one is Apple, Microsoft, the ExxonMobil, and the SPX. Right? There are how many? 2,214 rows, and the data start from 2003 to 2011. So what we are going to check, we are going to check the correlation with all the group with respect to the SPX. So this is, it takes the group as the input, and with that group, it will check the correlation with the SPX. So let's first calculate the returns, and you can calculate using the percentage change function and drop any if there are any, right? And here I'm just getting the year of that particular group. So I'm just grouping the return which I got using the get year here. And let's see the returns or the correlation with respect to the SPX. So what we did on this group, we have applied the function SPX correlates, which is with this group is how it is correlating with the SPX. So there are 4 groups, right? Apple, Microsoft, ExxonMobil, and the SPX. And as you can see, SPX with SPX, of course, it's one because it is 100% correlated, and the other three indus companies are correlating. So as you can see, the Apple is correlation is been increasing from starting 2003 to 2011, almost like 70%. So it's highly correlated with the SPX. Next, let's see the group transformation and unwrapped by group by. So what we'll see what mean by unwrapped here. So let's create the data frame. We have ABC multiply 4, so 12 values and 12 1 to 12 keys and the values. We are going to group by using the keys. So there are going to be three groups, and let's see the values. So A, B, C, and it just calculates the mean. You can also use the transform function, which is very similar to apply. It just take the function which you have created right in this. It's just taking the group as the argument and calculating the mean. So if I run this, so it's provided against each value. It has substituted by the mean value of that particular group. You can also do the same operation by just putting the mean as the baseline function. It gave the same output which was there. You can multiply by 2, right? So this is what each value will be multiplied by 2. Here we replace by the mean. Here we are just multiplying by 2. Next, we are just getting the rank of each group, right? So starting with 4, 3, 2, 1, we have kept as heading as false. Normalize is nothing but it just normalize your data as with respect to the we are doing the subtraction by the mean and then dividing that particular with the standard deviation. Let's see how the data looks like. So just convert your uh, normalize your given data into based on the subtraction from the mean and the division by the standard deviation. You can use the apply and it is going to result in the same thing with the keys are representing these ABC, right? These are the groups, these are the values. And G transform, we have also see you can do that. So uh, here what we are doing, we are doing the arithmetic between the groups, between the output of the multiple group operation instead of writing the function. So earlier we wrote the function right here. Sorry. Yes, here normalizing, right? So instead of doing this function, we can directly calculate it. So this is the value minus the mean and dividing the standard deviation. This is the same thing, same operation, but this is what we call unwrapped. It's because instead of writing a function and passing it to the group by, that is what is meant by the unwrap. So we are directly using the columns to do the analysis, to do the computation on the values in the columns. The last two are the pivot table and the cross table. So you might have seen the Excel, we do a lot of analysis by using the pivots, right? Pivot chart and or you can do the normal pivot. So similarly, you can do in the pandas also. So let's load the tips data set. Right? This is what we have. I just drop few columns, added one tips percentage, and here I'm just pivoting based on the day and smoker, and this is what these values means. They are the mean by default. You can use any additional functions. So there is a argument called argagg function. I will show you in a second. Next, here we are doing the pivot based on index is our day, columns is smoker, and the value is the size. So as you can see, the column is smoker, right? Index is day, and this is being pivoted into the size. You can use the margin true to get all the rows and the column data as well. So this is for the size and this is for the remaining other columns. Here, instead of getting the mean, as I told you, can use any other functions. Like in this case, just to highlight the what is the length, you can it is giving the length of that particular value. And if there are any values, how to deal with that? So you can use fill any with the any substitute value, 0 or 1 or any other values, right? So that's how you can, so this value, the whatever have been written are the null values earlier. Lastly, the cross tabulation is a special type of pivot table that computes the group frequencies. Okay, so let me load some data. We have a data and let's convert this into data frame. So I'm just reading this from the read table, importing the IO library with the string IO as the function, putting the data because it was separated by space, right? As you can see, this is space and convert into data and then put the cross tab of nationality with handness and see what see. So how many people are left-handed, right-handed, and what about the other, right? And again, you can do the cross tab for this on the tips data sets as well to highlight the your in the index the days and cross tab with the smokers, no, yes, and what are the all. So that's what is we are almost done with the data aggregation, the group operation. I suggest you to look into the couple of this and the part one to get the complete picture. We have covered a lot of inbuilt and the user defined functions, how to deal with the data aggregation and how to perform the groups in the pandas and Python. Thank you. Hello everyone. So we have seen the data aggregation and the data grouping in the last video, and now we'll shift our focus to the time series, how to handle the time series data in the Python and especially in the pandas or numpys and using different other libraries. So time series data is available in almost like every industry. If you're working in the energy industry, there are the sensors data which we get periodically at some time, right? It can be daily or weekly or maybe within some time, right? Hourly, half an hour, maybe in minutes. In financials, we have a stock data, right? Which have different frequency. You will get 1 second data to, and your data keep fluctuating based on the number, the volumes, and the stock price is move in either in the upward direction or the downward direction. And likewise, there are other fields also where the time series data is available. And let's see, we'll see some of the examples here on the time series. So let's start by loading our library. So we are going to use the NumPy, pandas, and the date time, right? And using the date time, so dot now represent what is the current time, right? And it will just give you, I'm just putting that in the now, and it will give you the date time. This is 2023, 7th month, second day of July, right? And this is the time. And now you can also extract the each component of this date time, like now.year, now.month, and now.day. So year is 2023, month is 7th, day is 2. You can also find the difference between the two dates. So date time, and if you just provide this numbers like the year, month, and date, it will automate. It will you can do the certain operation like the subtraction, addition, right? In this, the delta will represent the change or difference between the two entity, and here we can see the time delta here is days 926 between 2008 and 2011, and the number of seconds. And you can extract using the date, how many days are there in the second. Same data you can, if you want to use, you can extract those. So as I told, the date time you can provide these parameters and it will convert into the date. And using the time delta, right? We have imported time delta from the date time library, and it will. So what I'm asking here, time delta plus 12, right? So we started with the 7, all right, and it just added the plus 7, plus 12 into the date, right? You can do the multiplication also here in this case, multiply by 12 into 2 and do the minus. So it just moved back to the move it backward in the time. You can also do the conversion from the string and date time. So let's say this is the date time, right? You have a stamp as it says date time, it's represent year, your month, your date, right? And you can convert this into a string, right, using str. So now this is converted to string. You can see the quotation, and also from the string to time, what you can do, you call the function strf time and provide the format in which you want to convert your date into the string. Let Yeah, let's keep the one value in the value one date as a string. So this is a string, right? It's we can see it's a date, but it is a string, and you can convert the value from string to the time using strp function, right? Let me run this and let me run this. So and it will provide. So what it did, it passed the new date time from the string. That's what string passed from time. Uh, String passed to time. So that's what it means. So what I'm doing here is it's you can see there is a list and there's a two values, right? And I'm just calling one value and changing those values which are in string format into the time format. So this is what date time. Yeah. Next one is the date str. Again, you can convert to the date time using a two date time function here, right? And also one important thing is the date time. You can also include the none. So if I just do there, so what it means there are two dates, right? Date str, two dates are there, and plus none means NAT not a time value also been means rendered in using the date time index, and we can also fetch it using the slicing or indexing. So let's start with some of the basic in the time series. So we have this dates uh, list here, right? It's a date, time, and what we can do, we can create a series. So these are six different value and indexing. We are using this indexing, and that's what the normal, very basic time series data looks like. So in the indexing, you always have a some point in a time. Those can be uniform, means it will be like after every 5 minutes or after every 1 hour, or it can be ununiform, means at certain point in time, different point in time, the data value is available. You can extract the index. So we have kept the dates as that, and using ts.index you will find all the indexing, right? And you can see that data type is date time. Next, you can also do the addition. So starting from first, every second, every the other one is NaN, right? Because the values you can do the addition of, and if you are doing addition of something on NaN, it is definitely going to print. So if I just do this ts, so only three values are there, 2, 7, and 10, and that's why 2, 7, 10 are addition from the previous. So what was ts, right? Only 2, 7, and 10. If your values have been updated with the values that are then, because if you do let's say 3 plus none, so you will get the error, right? Next is the again you can, if you want to find out what a date type, you can use index or d type. Next, let's see the indexing, selection, and subsetting. So as I told, using the indexing, you can call, okay, at 2, what was the timestamp there, right? If I call again ts, so 0, 1, 2, right? 0, 1, 2, this one value. And also if you can provide the full date, and it's going to convert it, and means the what it is doing, it is just checking the index, and what are the values at their 10, it is just giving that as the output. Let's create a big longer time series data. So it's a thousands rows, and we are using the pd dot range, means starting from this to the thousand period it's going to create. And this is the, so it's a frequency is a day, right? And length is 1000 because we have given 1000, and the data type is float 64. You can give us the year only, and it will extract all the values related to year. So though you're not giving the full value, only for the year part, it automatically sees and grab the values. So as you can see, for 2001 there are 365 days, and that's what it been extracted. You can provide the year plus month, then it will just show the year plus month values starting from, you can see, 01 to 31. And you can do the indexing of providing the values of the index, like starting from this, give the values 6, 7, 8 to the remaining one, right? Similarly for this one, if you want to select some range, you can do the slicing using the indexing in the time series. What happens if there is a duplicate indices, and that is very much possibility in the real time data. As you can see, so this 0, 1, 2, 2, 2, so these are three duplicate value and there is a 3, right? And we are just creating a number 0 to 4 indexes. As you can see, 1 is 1, 2 3, 2 are 3, and duplicate value, and this 3. And you can check whether this duplicate time series index is unique. It will be false. You can also, if you call this, you should get three values because these are duplicate. And if you are calling this index, it's not a duplicate, so it will give you the exact value. You can do the group by again by providing the levels, and you can again do the certain functions like mean and count on the group, whatever you have created based on the level. So level is nothing but how many levels are there. So it's only zero level, right? 0, 2, 3. Let's look at the date range, frequency, and shifting. So this is the time series we have, and we can do the conversion. So conversion is we use resample, right? And it just convert your data, which is let's say if it is giving in months, you can convert it into days. If you're giving days, you can convert into month. There are two type of resampling, that is the down resampling and up resampling. So I'm going to provide more detail on these two categories, but here what we are saying, okay, resample it based on the day. More to come on this resample. We'll be creating a separate heading and topic for that. So let's see, generating date range we have already used. So in the pandas.date range, you can provide the start or end, and we am just putting into index variable. So it start with 041 and goes to 6 uh, June 1st, right? And you can also provide the periods. Okay, I want to start here and give me the period. So automatically it takes the day as the by default day as the frequency, but you can change that, right? And also, so you start with this, and in this case we are saying, and this means this should be the last value and give me all the 20 plus value before that. So that's why this is the last value and all the other 20 values are before that. So it goes into the reverse. Also, if you want to create a date range, BM represent the business month end. There are many different type of it, quarter end, month end, weekend, right? So there are, you can provide those parameters in the frequency, and the same will be available for, it will render same similarly whatever frequency you provide here. So here, if one important thing, we are providing also time and creating, okay, create a 5 period, right, date range. So this time will be same for all, right? You can see it's 0, 3, 4, 5, 6, but the time is static, so it's preserve the time. And also if you want to don't want to use that and you want to keep as a midnight as timestamp where the day changes, so you can just provide no normalize it and give me all the 5 period, so the time part is removed. So let's see the frequency and data here. So I'm also importing the pandas time series offset and importing r and minutes. So r is nothing but the functions available, right? And you can do more operations. So I'm just providing r4. So it is a 4r. So whatever the value is will there in the 4, it will multiply by 4. Similarly, you can also provide in the date range the frequency like this 4h. 4h means 4 hours, right? As you can see, the 0, 1, 0. 4, 8. So every this the addition of 4 hours is being added to each element of the list. And similarly, you can add 2 R2 and 30, so it will be like 150 minutes, right? Convert into 150 minutes. You can also provide the frequency something like 1 hour 30 minutes, right? And what it means, so it is just adding 1 hour 30 minutes to each readings, and the 90 represent is the 90 minutes. So T here is represent the minutes. Weeks of month, so you can also provide like week of month, third Friday. Give me the third Friday from this one. So these values are the third Friday of a week of month. And the mostly dates again, the same thing. I'm just providing converting it to list. Next is the shift lagging, leading and lagging date. So there will be a scenario where you want to add two more dates, start by +2 or -2. Let's see how we can do that. So these are four values. Index is starting with this period 4, frequency is month. So our first January, February, March, April, right? And now we are saying shift this time series to 2. So shift is a function which is used to shift the timing in the time series data. So as you can see, there is no change in the index, but the values has been shifted from 0, 1, and -4 became the third and fourth. So because there is no value, it is not a number. None is being added to the first two value. You can also go in the backward, right? So this 0, 1, and 0, 2 got shifted to -2. You can also add the frequency like okay shift but shift as the month. So that's what it means. Here it says shift per day. Right? So start with 0, 2, 3, 4, 5. And also you can shift with the minutes. So here what is being same value but it is being added. The frequency is 30 90 minutes here. You can do the offset. Offset is nothing but let's uh, import the day and month end from the offset, and let's add now. So this is the date, and I just want to maybe let's keep it today dates 702, right? And I want to add 3 days. So what is the 3 days? So it will be 5th of July. What is the month end? This is the month end. What is the previous month end? What is the month end for next 2 months end? So after it will be August, right? Offset, we are adding it, and rollback now means forward rollback. So there are two type of rollback. Give me the current and give me the previous. So it shows the previous because we are the month end, right? So what is the roll forward means? Give me the this month end, and if I say roll back, give me the previous month end because we are asking for the month end. Let's create a one time series of 20 readings, and 4D means it's the offset is 4 days. So frequency here is 1, 5, 9, 13 like that. And I want to group it TS group by month end. So month end and roll forward means this month end and what is the mean of it. So it just goes it looks for this is the one group, right? This is the second group and this is the third group. And for each month it is just giving the mean of the values. Same thing you can do using the resample. So resample is again I told you it is used for converting from different frequencies. So this was date and I'm saying convert to the month and give the mean. So same output with uh, less coordinate statement. Also I want to touch base on the time zone. So there is a Python time zone library is there, and it is used like okay, what are the common time zones? These are all the common time zones, and you can see okay, what is the American and New York time right now, right? And that's what it will give you time zone for the American Europe, and you can convert those. So there is, let's say this is the date, and I'm just adding 6 periods starting from 6 30th of June, and now I'm adding the creating the time series data. Okay, and just to print, okay, what is the time zone of this series? So there is none. So to add that, you can provide the additional argument TZ, which represent time zone, and UTC is a coordinated universal time, and all your data you will now has the time zone of plus, right? You can see the plus values here. So this represents the time zone, and you can also localize it using the TZ underscore localized to time. So what if, let's say, you are using the American and you want to use UTC, or you want to use the local for let's say in Europe, so you can convert using UTC by this function TZ under localize. And for converting it to different, you have to use the TZ under convert. So that's how we handle the time zone. So we have covered a lot in this, starting from the converting between string and if your values are a string, how to convert it into the date time. There are two functions, str time, str time, right? F time and p time. We got few of the basics, how to index. Again, it is in the time series, your index is mostly the time frequency, and you can do the indexing, how to handle the duplicate. Next, we checked, okay, how to do the date range, how to use date range of function of the pandas to create indexings, right? Also, how to do the offset, check the frequency, how to do the shifting of leading and lagging dates, right? And how to use the offset, and also we look at the time zone. So I will continue this time series. We have to cover a few more important topics before we move into the next section. Thank you. Hello everyone. So to continuing our discussion on the time series data, let's deep dive into our other few subtopics. So I'm just load the libraries, and we are going to first discuss period and period arithmetic. So what does mean by that? As a frequency, you can put multiple periods which start with like 8 December, that means the year end. And let's see what is, so in this PD dot period, which is with the capital P, and this 2011 represent the full period of year end, right? So if I do plus 5, so that start with 2011 plus 5, 2016, minus 2, 2009, right? And again, if if I do the 15, 2015 plus a December, that means that 4 multiplied by the year end. So I'm doing the minus of it. So 2011 minus 2015, what is this? The 4 years gap, right? You can do a period range. So period range, you have to use pandas dot period range, the start and the end and the month. So it will be like January, February, March, April, May, June, right? Year and the month, and the period is month. You can use this as the index, and this is the time series which has index as the years and the month. Next, if we look at the period frequency conversion, so again, we'll start with having this period with 2011. It's this till the year end, right? So if you want to see when this is starting, right? So you can see as frequency, period means p dot as frequency within the as month, show me as a month and show when it starts. So it start with 01 and it's at with 0 12. So as I tell, this represent the year end. So we are, this is a period of 2011, and this is the pictorial representation. So this is a period of 2011. A December means till year end, right? It start with January, it end with December. And if I say period 2011 minus 6, so this represents June because it's we are asking for a month, right? And let's move to next. So you can also do a period range by only assigning the years, in this 2006 to 2009, and A December again, which is what? The year end, right? And let's use this as the index and normal values of photos 2006, 7, 8, 9. So that's what the our range 2006 to 2009 as the year end. And again, you can check each period will start with the first month and each period will end with the 12th month. Quarterly period frequency. Again, in timestamp, you will, if it is the financial data, you will also have a lot of quarterly data. And that's what is, you can have multiple types here. So the pandas dot period this is a 2011 start with quarter 4 and frequency is Q Gen. So what is meant by Q Gen, right? So let's see. So it start with January. Uh, so it start with November and it end with the January. So that's the quarter end of January. And similarly, we have other three types. So these are the months, right? Q December means it start with this will be your first quarter, second quarter, third quarter, fourth quarter. If it is September, so September to December will be first. This will be second. Right? This is the first. This is second. This is third. This is fourth. And Q Fab means the Q December will month will be the Q4, and the other two Q4 will be Jan and Feb, right? And then it start with December and followed by other 3 months like that. Converting timestamp to period and back. So you can change the times using the timestamp. You can change to the periods or vice versa. So let's create a date range with 2000 with period 3 and month. So only January, February, March, and use this in our time series. So it says month because it's a January, it's a February, and it's a March, and these are the random values from standard normal. And I want to convert this TS to period. Okay. So what is mean by the period? Only the years and the month, right? And let's start with January 29th and the period says so by default it will take as the day, right? And so this is 29, 30, then next month I'll start it and use this into create a new time series called TTS2. So it starts with the January 29, 30, 31, then the February, right? And now let's convert this to period months. So what do you think it will be? So there are 2 months here, right? So it starts with, so this belongs to January and this belongs to February, three readings. And if you want to convert this to, this is the same thing of the days, right? Here you can see the frequency is days, above the frequency was month. And you can convert this part to timestamp and how you can end. So what is means by it start with again the date is same, but it also have a timestamp of the last hour, right? And the end hour. So you can also make the start, right? Let me creating period index from array, and this is which I have seen earlier also. So we have a macro data, financial macro data, the year, quarter, right, and all the other variables. And now we can see okay, this has a year data also, this has the quarter data also, and we can combine year and quarter like year 51, quarter Q1, Q2, and that can be achieved using the period index. So pandas dot period index, you provide the year data, you provide the quarter data, and the frequency is Q December, right? So that's the index, and you can use data dot index to this. Now instead of index 10123, it has the Q5, Q1, Q2, Q3. So all your quarter and year is combined and created as the index here. Resampling and frequency conversion. So resampling we discussed in the last video. Also, resampling means you can convert your frequency, the indexing if it is from days to month, months to days, and there are two types: the downscaling resampling and the up resampling. So let's see that. So this is a date range. We start with 2000, make it for 100 days, right? And use this in our time series. And now because as you can see, the index is in the days, and we want to convert into the month. So provide your time series dot resample and m represent here months and give me the mean. So as you can see, this goes till how many? 4 months, right? So it starts with Feb, January till March, April. And the mean of each month is represented here. You can also provide the kind period you want to convert period, but if you're not providing, it's still producing the same result. Now this, let's first see the downsampling. So downsampling is aggregating from higher to lower frequency. So what it's happened in downsampling, it first divide your data into the beans and slice and then convert it. So let's create a date range from 0, 1 to 12 and T represent the minutes. Okay. So these are the each minute, right? Create a time series and now converts the 1 minute into the 5 minutes, right? So you have to just provide 5 minutes and sum. So there is one more parameter here closed, which represent at which end you are including the reading. So let's say you have a 5, 0, 1, 2, 3, 4. So are you including 4 or are you including 0? So to do that, you have to use closed where you are closing the that bin. So like in the histogram, right? You have a you start and your end, and the exclusive the bracket represent the square bracket represent you are including that value. So similarly, so if we start put the close as right, so it goes one. As you can see, we created the series with 2001, but it goes will 1990, 12, 31, right? And similarly, you can put the label also to right and left, and it will change the indexing in the correct manner. So if you are aware of the stock market, you might be aware of the open high close low. So the stock price of any ticker will have something. It's start with some value, and throughout the day it make a high, it make a low, and that is closes, right? So it is same thing, open high close low. So let's create one time series. It is based on the indexing, right? We have it in the minutes, and these are some of the value. And now let's resample this and also put this into the OHLC function. So what happens here, it divided this data into three 5 minutes brackets, right? 0, 5, 10, and then added open high close. So if I go 0 to 5, right? So this is the one, right? And it is not including the 3 here. Okay, so 25078. So what is the maximum is 8. What is the open? It's 2. And what is the ending? 8. What is the low? 0. So that's how, without doing any much writing a big code, the Python has already provided this function of SQL to do that. Upscaling. So upsampling represent the converting your lower frequency to higher frequency. In this case, this does not divide data into bins. It automatically created. So let's create one data frame of 2 by 4. It's the date range is 2001, period is 2, and the frequency is week Wednesday. Okay. So this is what the data frame looks like. The first variant is 05, the second variant is 12, and you can convert this into days, right? So as you can see, the days there are the between one Wednesday and the next Wednesday there are empty data, right? And you can fill this data using F forward fill. So all this value will be cascaded to the below, right? And so that's what the upscaling is. So you convert your higher frequency to the lower, right? Sorry, I told it lower frequency to the higher one. So weekdays to the days. Resampling with the period. So let's create one data frame, right? We have 24 by 4. The date range start with first month 2000 and to the 12th. So it's 14, right? 24, 2001. Month is some frequency based on the months and column is ABCD. We can resample with a dash means divide into the year level of resampling, right? And that is, and we are also getting the mean of each column here. You can do the QDS, right? Quarterly and quarterly of March, and it's again it's provide the forward fill. Next, we'll look at some of the moving window functions which represent the you have the calculated values based on the previous value. So we have a stock data here of Apple, Microsoft, ExxonMobil, right? These are the time index is the times, and these are their values. And let's see so what we are doing here, we are resampling based on the business end, right? And if any values are none, we are fulfilling it. And let's plot the chart of the Apple. So this is what the Apple looks like in 2003 to 2012, the significant growth in this stock, right? And now let's see what is the rolling 20. So again, we are going to plot the same data, plus we are going to do or call the rolling 250. That means give me the rolling means cumulative value, average value of that, and let's plot that. So in the this plot, you can see the blue represent the actual close data of that particular day, and this is the average line between with during that whole time series, right? 2003 to 2007, and this is the value. So this is the average value of moving average of 250 days. You can have the standard. So in this, we have the same thing. We are just checking the percentage change and the rolling window of 250. Minimum period is 10, and to calculate the standard deviation. So this is the standard deviation looks like. And if you plot this, it will give me during during that year, particular year, what is the standard deviation value of that particular stock in this Apple, and what is the standard value, right? You can see the from the mean it goes to 0.10 till 0.035. You can also calculate the expanding mean. There is a function called expanding, and it will give the results. Also, if you want to calculate rolling for all, so you can just like this. So as you can see, the Microsoft and the Exxon Mobil, they have a very uniform or linear growth. On the other hand, the Apple was growing almost like the exponential growth. We can convert this into this axis, the y-axis, into the logarithmic, while log y equals to true. And lastly, just if you want to calculate the rolling 20-day, you can just put down this value, and each value is calculated as the rolling value, rolling average mean value of all the columns available in the data frame. Similarly, as the rolling, you can have the exponential weighted function. So let's get the Apple data from 2006 to 2007, and let's create the moving average of 30 days and exponentially weighted moving average of 30 days, and let's plot this. So this is what the value looks like. So as you can see, the exponential weighted moving average is more aligned toward the actual compared to the simple moving average. Next, we have a binary moving function. So here we are calling the separating the SPX index. Percentage change, we are just how much percentage getting changed from the previous value, and return of all the three, right? So let's do the correlation between the Apple return of rolling window of 125 days with the SPX returns. And if you plot that, you can see the correlation between the apples and the SPX returns. It's fluctuating, right? In terms of it is very less, but in the other, it is highly correlated of the SPX returns. And you can do it for all three, right? It's a bit busy chart, not giving more insight, but you can, if you have multiple tickers in your dataset, you can do that. Also, you can have a user-defined moving function. Let's have the percentile of score. Means it's a 2% rank of the 2% of the Apple return over the 1 year window. And if you result it, so as you can see, the percentile rank of 2% of the Apple return over 1 year window. This is how it looks like. And if you want to get more information about the SciPy stat percentile of score, you can of course you can put the question mark and it will give you all the results. So percentile of score, it's compute the percentile rank of the score related to the list of the score, right? So for example, 80% mean that 80% of the score in A are below the given score. So that's what we deviated toward the financial data, but we are going to discuss a lot of other examples. And before we end this data analysis series, so stay tuned. Thank you.